Assalamu alaikum warahmatullahi ta'ala wa barakatuh. Ladies and gentlemen, welcome back to another live stream. So this is the first live stream that we're doing after I got sick last video. And yeah, right now I just recovered. Okay. So let me see what's happening here. I gotta share the live stream. Let me see if everything is going well. Let me see if everything nice. Copy video. Let's go and okay. Please make sure to join my Discord, so my Discord server, so you can actually vote for next live streams, and also just hang out with the community. Alright, so everyone, and also get notified of live streams just like I'm doing right now. Okay, let's see, send now. Alright, nice, lovely. Okay, pretty cool, pretty cool. And Marty Flowers, hello, welcome to the live stream. How's it going? I'm glad you're here. Okay. Came a minute ago, but the chat takes forever to load. Alright, is everything well? Is the recording well? I have just installed Linux once again. I keep on switching between Linux and Windows. But yeah, we'll see. Alright, pretty cool stuff, huh? Nice. Yes, stream is solid so far. Amazing. Alright, so since I just installed Linux, you can see the whole process of installing that stuff, other than of course installing OBS and what it required. It required, I think, CMake and CMake and I guess pkg config, though I had a segmentation fault with OBS, so I just had to fix something. Basically, I removed, I think, libva of NVIDIA or something like that, and then I just installed an open source alternative, and OBS is working again. Alright, nice. Other than that, yeah, that's pretty much it. Now let's just go ahead, and Marty Flowers have suggested me to look into Qt Creator, and we're gonna try that out. I'm going to see, and if it doesn't work out, we're just gonna switch to VS Code pretty much. But let's give a chance to Qt Creator pretty much. So yeah. Alrighty. Okay, I just selected all the optional features just to make sure I'm not missing out on anything. Alright, pretty cool. That's gonna be interesting. Yes. In the future, we may try to use Qt GUIs with Vulkan. We'll see how that goes. I never really tried it, but yeah, pretty much. Other than that, I tried Vulkan for cross-platform, and I kind of have like an OCD or something like that for being cross-platform and coding well, I guess. So that's why I end up a lot of times just burning out myself with projects and just abandoning them at the end of the day. But hopefully right now, since I'm going to be using XCB, which is Linux only, which means I'm locked out of cross-platform, so I'm just gonna be caring about making it work on my machine essentially. So, and my scope is much much smaller. Anyways, Pretty cool. That also would allow us to use modern Vulkan with no problems, since we don't care about cross-platform, etc., etc. All right, pretty cool stuff. Will you be using Vim in the future for the Zig language? For now, I'm not gonna be using Zig. From now on, I think I'll probably just be using C++. Um, just to keep my health in check. To keep my sanity, but yeah, pretty much. Although I don't really like love C++ so much, but you got the point. It's just like the standard for such things like graphics programming and stuff. So, and it works, I guess. But yeah, anyways, I'm just forcing myself on C++ pretty much for now. All right, so yeah, okay, we have Qt Creator. Qt Creator. Did I install that or what? Better old known than new to know. Qt. Why didn't it install? Weird. Lunch. I don't know why it didn't show up there, but anyways, who cares? All right, so there you go. It was that easy. Cool. Now let's try to create a project. All right, let's see. So this is my first time trying out Qt, though I opened it once in my old installation of Windows just to see if it even works. But I pretty much still, this is kind of like fresh. But anyways, so there is application Qt or non-Qt project. We're gonna go with this one, plain C++ application, and choose. So as I said, if Qt Creator doesn't work for us, we'll switch back to VS Code, and yeah, pretty much. So creates a simple C++ application with no dependencies. The name. Well, the name is the primate. Oh my god. Alright, Codoxel or let's see, Codoxel or what is it else? And so either Codoxel or there's another cool name that I actually remember. Let's see if I can remember it. Codoxel. Well, I don't remember. Anyways. Oh yeah, I think it was Codoxalic or something like that. I don't know. Anyways, let's go with a cool name like Codoxel. Why not? Use as default project location. Browse, right? Kodotaku. Let's create a folder here just for the sake of. Okay, and let's call this, I guess, projects maybe. And then maybe choose create in projects. Is this like the top level directory or is it the actual directory? Create in. I honestly don't know. Anyways, next. Build system, of course, CMake. And desktop. Ooh. Top level, okay. Manage. Yeah, I did actually wanted to install LLVM tools. I actually forgot about that. Let me make sure I have LLVM tools before doing all this stuff, just to make sure it goes well, because I'd like to use Clang stuff, etc. Oh yeah, so LLVM is already here, seems like. Pretty cool. What else I wanted? Yeah, pretty cool. LLVM is there. Alright, so I just wasted time. Anyways, where is Qt Creator? Oh my god, I don't know why it doesn't show up there. Anyways, lunch, and I'm just gonna pin this guy, by the way. And yeah, remove this. Create project, plain C++ application, choose name, Codoxel. Let's go next. Right, next. Desktop, what is it using? Auto detected. So C, GCC, and Clang. Nice, lovely. The debuggers are also there, pretty cool, huh? Next, and add to version control, why not? Right, and finish, I think. And oh my god, my eyes. Where is how to switch the theme. I guess preferences maybe. And then there you go. Theme. Dark. Okay, I need to restart. Oh my god, not this dark. Hold on. Let me see the other themes. Design dark? Okay, that's better. Alright, that's better. Nice, lovely preferences. That's new before it takes it at its own theme. Okay, toolbars style, compact or relaxed. What about relaxed? Enable high DPI. Don't have a high DPI thing. Pretty cool. Looks good. Okay. Behavior, display, tab size 8. What the? I don't know about that. Anyways, generic highlighter, snippets, macro. Anyways, so what else? C++, override Clang format file. Full formatting, please. Format edited code on file save. Sure. Override, no. And I guess it's gonna be using LLVM as the style. I don't like that so much. Is indentation in code lines? Oh yeah. LLVM. Can I change this? How do you change this? Why it's grayed out? Oh, current settings. Qt. Is it? GNU? Weird. Yeah, I guess maybe. What the? Click on copy. Oh. I'm in Qt copy now, but how do I change it now? I still can't change anything. Interesting. Oh, it's actually using Clang format. Sorry. All right, let's just get it back. Okay, never mind. I see now what's going on here. I see what's going on. No, it's not letting me because it's using the Clang format file. Okay. Yeah. Qt copy. I'd like to use Clang formats, so because it's not really like linked to the editor. You could use whatever editor and you'd still be able to use that. Anyways, remove this guy right here. I'm just gonna be with Qt built in, who cares? Okay, other than that, the file naming, I'd like to go with HPP, please. Prefixes, include guard, use pragma once, please. Sources, suffix, sure, CPP. Prefixes, lowercase file names, yeah, sure. License template, code model. I don't know about that. Quick fixes, Clang D. Use Clang D, sure. Right, nice, lovely. Yeah, I think that's pretty much it, maybe. There's even a fake Vim. That would be interesting to try out later. Anyways, build and run. Save all files before build, please. Always ask before stopping applications. Word wrap output. Okay, I think we're pretty much set. Auto run CMake. Formatter. Please, automatic formatting on file save. Tools. Yeah, I think we're all good. I should have added Qt Creator to the title of the live stream too. Alright. And the nice thing about Qt Creator, at least it seems like, that later on when we might want to start a new project that supports Android, it's probably much easier to do so with it instead of something like VS Code, I guess. I don't know. Anyways, so is auto formatting on, by the way? Enable auto format on file save. Restrict to files, that is very cool. Nice. Okay, so that's pretty much it, I believe. That's pretty much it. Now, this is trash code. Never do that. cdc out, okay. cd end line. Alright. I see. I don't quite like this. And to change that, I think we need to add the Clang format file. How do you do that? Ooh, GLSL, amazing, nice. Okay, empty file, I guess. Choose file name. I guess it should be Clang format. Nice. Finish. And there you go. Now I have Clang format. I don't know what's that. Anyways, let's look for some Clang format stuff. Hold on, new window. Clang format. Let's see. Let's see. Come on, where is the file? Duh. There you go. Alright, lovely. This is what I want. So language CPP. I don't know if I want to base my style on Google or not. I guess so. Why not? And let's see if this actually works out. Let's see. Does this works now? Alright, let's go. Lovely. Lovely. Alright, so that's pretty cool. Also, something about tabs. Use tab never. Always use that. And for tab width, I'm going to go with 4. This is pretty important for open source projects. So whatever whichever IDE the other people are using, they will have the same experience, like same formatting, the same everything basically. By the way, does Qt use Clang to die or not? Do you have any idea? Clang to die. Okay, I mean it's right here. Nice. Okay, I'll also add that, I guess. How do you add it? Clang to die. Where is it? Add new. It's gonna take me some time to memorize this stuff. Anyways, .clang to die. Finish. Or tidy, or I don't know how it's spelled. Anyways, oh, it's actually adds it. Nah, that's not correct. And this is so stupid. Seems like this is a legacy CMake stuff. I don't know what's that even that. But I don't know if this would like, if I removed it, I don't know if it would like break it or something. I don't know. Anyways, so for git set CMake cxx standard, I don't need this stuff honestly. And for this I'm just gonna comment it out just in case. And I'm gonna say target And let's see, target compile features, and this is how you do it with the new stuff. I always like to use the project name variable. Oopsies. There you go, nice. Okay, CXX, well, private. Fun fact here, SDL3 C++23 template works in Qt Creator by just opening the CMake file. Yeah, my CMake, I always try to self-contain my projects as much as possible. So you just clone your thing, you run CMake, and it just works. It doesn't depend on system as much as possible. But I don't know how I'm going to do that with XCB, since I don't think XCB have a CMake file. So I'm not sure. For now, I'm just going to be using the XCB system library, but later on I may try to actually self-contain that. Anyways, I always like to have all the source code on my project, but you'll see, like, I really learned a lot about modern CMake these days while I wasn't live streaming. But anyways, so project name private and CXX std23. This is pretty much how you do it in modern CMake. And in this case, as you can see, I'm using C++ standard 23. So basically C++ 23, right? And then, all right, looking pretty good so far. What else I wanted? Oh yeah, I don't know if I'm gonna go with this one, but I'm going to try to go with compile options. All right, project name private. Okay, and then I'm gonna go with -w all -w. Let's see, -w all -w extra -w pedantic. I may remove this warning since sometimes they're just so irritating, but for now, yeah, there you go. If you can work with them, awesome. Alright, so I think that's pretty much it. Now, alright, lovely. Now let's go to the next step, which is packages, how we're gonna get Vulkan headers package, how we're gonna get all that crazy stuff. Anyways, so let's see. I'd like to use CPM. It's very simple. Oh my god, not this. CPM GitHub. There you go. Well, not this one. I very much recommend using this. It's basically a wrapper over fetch content of CMake. So I'm not going to be using submodules anymore, Git submodules. They're just, I don't know, so clunky. And so, yeah, pretty much. So how am I going to deal with this? All right, let's see. So if you go to add in CPM, there's a lot of ways that you could add CPM. You could even just embed one CMake file into your projects, and there you go. It's just a CMake script. But in my case, I just like to go ahead, copy this stuff, and let CMake download CPM for me. Why not? Okay, pretty cool. Now we have CPM done. CPM packages now. Now for the CPM packages, we're gonna go with the Vulkan headers. I don't like to depend on the system headers. So we're gonna go with this one. You gotta go to releases. I'd like to use a release. Okay, cool. Now here's how you add a package using CPM. So add CPM package, if I remember correctly. And then you could essentially say gh, and then you add this guy right here, and then you can add the tag. In my case, I'm gonna go with the SDK version. The SDK versions are more stable, and I do recommend using them for production. This is the latest one though, but it's not the SDK version. So yeah, anyways, I just recommend going with the latest SDK version though. Alright, pretty cool. And CPM package, nice. The other thing that I'd like to go with is, I believe, Vulk. Okay, so Vulk. Oh my god, come on, bro. Come on. Come on. Okay. let's go. Alright, so you gotta go with this guy. Vulkan. Okay, well, in fact, let me just copy this guy again. And let's go with this guy, copy Vulkan. Alright, lovely. Now there is some releases here. You could go with the latest version, by the way, but yeah. Alright, so this is the latest release. And that's the tag, isn't it? Yes, that's the tag. Nice. So, by the way, you may want to use the same SDK version as the as Vulkan, but I didn't have any problems with that, so I'm just ignoring that. All right. Other than that, we need to add VMA, Vulkan Memory Allocator. It's very much the best Vulkan allocator out there. It's a must-have, unless if you're very expert genius on Vulkan allocation and allocators in general, and you want to put in the work, go ahead. But I'm not that. I'm just a beginner. Okay. GPU open. Or if you have some special use cases, although it's usually the best way to go with something that someone have already done. But anyways, so here there is v3.01. Now you have two ways of doing this. Either use the tag like this, or you could switch it to a version like this, since the tag already contains a V, which works with CPM. Alright, pretty cool. Other than that, I think we're pretty much set up, or pretty much done. You could use the Vulkan headers of the system, but I don't like to do that. Alright, now let's actually bring in our executable, and I'd like to always put my executable as the last stage, and possibly even, I don't know what this source files is. Show in file system view. Okay, this is the file system view. Interesting. So let's actually create a new directory here. Add new folder. I'm gonna call this src, I believe, and then put the main.cpp here. How can I do that? What? I'm super confused. Main.cpp. Okay, this is much better. Alright, so we have an src folder that we have created. Let's put main.cpp there. Move here. Alright. Close. Okay, nice. Now that we have that, let's create a new CMake. Where is CMake? Duh. Why does God allow evil if he's all loving, all powerful, all knowing, so that in destroying should want to destroy if he loves us and he knows about the evil? All to be saved. Hello Husky, welcome to the live stream. And by the way, Sentis, welcome to the live stream. That's a pretty good question, though I could answer it later on in Discord. Just join my Discord and we can talk about that. There is a religion channel which you can ask that question there, and I may try to answer that. So yeah. Alright, so general markdown empty file. Okay, the file name is CMake list.txt, I believe. There you go. Add to version control. Nice, lovely. And I'm just gonna paste all that stuff there. And in my top level CMake, I'm just gonna go ahead and executable. Here I'm just gonna add subdirectory. Do you like to take a core? No. Add subdirectory and add src, I believe. And now let's see this actually works out. And oh yeah, I almost forgot. Target link libraries, and here we need the project name, private, and let's see. Okay, let's see what we want to link. I'd like to link XCB, I think, and Vulkan headers, and also I think it was, hold on, let's go to the web. All right, let's look into the CMake file here. Come on, Vulkan memory allocator, CMake list. Let's look for the target's name. I guess it's called this. All right, copy. And so pretty much what I'm showing here is that you could use this setup with all kinds of projects, mostly. You just gotta figure out the target names by checking out on CMake, and you'd get better in that with time. Or otherwise, search in the internet and you may find the target name. Just search and you may find like a Stack Overflow question that asks that or something. Anyways, Vulkan headers and GP open Vulkan memory allocator. What else did we add? Oh yeah, Vulk. So Vulk, here you go, nice. And yeah, pretty much I think. Let me make sure everything is working out now. Unknown CMake command add CPM package. I guess it's called CPM add package, maybe. Alright, let's see. Unknown CPM, oh my god, come on. Let me see, did I get it wrong or something? Let's see. CPM. I mean, it's CPM add package like this. Okay, hold on. I mean, yeah, I'm doing it right, so what's the problem? Unknown CMake command. Hold on, I'm going to close the window real quick. Alright, back. Okay, cool. So I'm not sure why it's doing this. CPM add package. That is supposed to work. Let's see, hold on. Let me make sure I have the chat on, by the way. Alright. Okay, this have never happened to me before. CPM add package. Oh, there is something wrong here, I guess. No? Hold on. Let me make sure it didn't mess up with the script or something. Oh, what happened there? I don't know. Anyways, let's try again. Where I can see the configuration. Yeah, where I can see the messages of the configuration. I don't know. Anyways, links to but the target was not found. Yeah, I think it's not that way. Let's try this guy. Let's see now. Build. What do you mean by ascend printf? Was not declared in that scope. What? Okay. Let's see. main.cpp. Run. Can you run that? Or did it fail? What do you mean by ascend printf was not declared? What the? Invalid value. What? What is that even supposed to mean? Let's try to use the 17 standard for now. For a second there. Let's see if that was the problem or something. It's pretty weird. Bro, what the? I don't know. What if I removed VMA for now? That's super weird. Let's just try to remove VMA for now, I guess. Let's keep it 23, but let's try to remove VMA for now. And let's see how that goes. Build. I mean, it worked fine for me on Windows. It seems like it's having some problem with in Linux. Oh, is it like 23 is not here already or what? I don't know. Let's try to use 20 then. I don't know. I mean, hold on a second. How can I know the standard that I have installed? I don't know. Anyways. So this works, right? Yes, hello world. Lovely. Okay. Other than the problem of ascend printf, I'm not sure why that's the case of the Vulkan memory allocator. Anyways, so now we could actually grab in Vulkan.h. And other than that, I'm going to also include XCB. Though I could probably actually, hold on a second, go to Vulkan.h. Instead of doing that on my own, I'm just gonna, let's see, there you go. Just define this and it will include XCB for you, I think. By the way, I didn't do this before, so if you don't know my live streams, I try stuff up in front of like live basically. So yeah, use of undeclared identifier. Okay, include this. Is there print? Oh no. CD. Bruh. I stream. Okay. All right. Let's see if everything is going well. Still, yeah. That was fast, honestly. Anyways, so now let's see if we have everything ready. Yeah, let's go. Nice, lovely. Okay, so auto connection, I believe. Okay. XCB connect null null ptr, and then here preferred screen number. Okay, first time using this IDE. Integer preferred screen number. Alright, nice. So is everything good? Used variable connection. Alright, lovely. Now let's check if there's any errors. So if XCB connection has error, I believe, yeah. Connection. Then if that's the case, alright, also gives the documentation. Nice, nice, lovely. So it returns greater than 0 if the connection is in error state, 0 otherwise. Nice. So if has error, how can I get the error? Yeah, it actually gives me the error. Nice. So if const auto status do that stuff. So const auto connection int preferred screen number. Lovely. Now other than that, we're gonna basically, okay, so I do need a login library. I don't like iStream that much. It's so we're gonna go with spd log, and here I am going to show you how to set up another library. Okay, so for spd log, let's see, spd log. So okay, let's go with let's actually go back to CMake list, and I'm gonna add another package, and you basically copy this guy. You can see that this way of doing it is much more self-contained and less problems. Alright, so there you go, and look for the release. It's look at the tag. Yeah, it's v1.12.0, and that should do it. Now go to back to here. Now most modern CMake libraries would be just like this. You just say the name of the library, colon colon, again the name of the library most of the time. So it's pretty much the same thing, if I remember well, with spd log, which is quite nice. And XCB, if you notice here that it is not a target, I'm just linking it with the system for now. Later on I may try to find out how can I do that, like self-contained. The nice thing about also having the source code is that you could actually step through with your debugger on the source code and see what's happening. And also you get to compile the stuff that you depend on depending on the configuration of CMake. So you have basically full control over everything essentially. But anyways, so how can I remove this? Okay, lovely. So now if we have a problem, what we're gonna do, we're gonna say spd log, I think. Yeah, spd log. Let me actually include that now. Include spd log.h. Lovely. Is the live stream fine so far, by the way? Spd log. And also, by the way, define VK no prototypes, because I'm not going to be linking to the Vulkan library statically. I'm going to be using Vulk for that, and also include Vulk.h. So yeah, I think that's pretty much it. Though I remember that Vulk maybe tries to link with the system headers, so I need to fix that, I think. Okay, hold on. If it seems like it's trying to link, where is Vulkan.h in this case? yeah, as you can see, it's trying to get the system header, which I don't like. I don't want it to depend on the system. So I gotta change this a bit. Okay, go back to CMake. So now instead of doing it this neat way, since Vulk is super annoying, we're gonna go with a little bit of a custom build kind of thing. Okay, here's how you do it. Go back to CPM and go to more snippets or whatever. Okay, there you go. Here's an example of how to do it. Actually, not this one. Hold on. Look for download only. There you go. So we only want to download it. So I'm just gonna do something similar to this essentially. Just copy this. I'm gonna do this, and instead of this, we're gonna go with, oops, the name Vulk, and the URL is actually not the URL. I'm gonna go with the Git repo. Yeah, GitHub repository. And then you just give it that guy, which is this. The version is, well, we don't have a version, we have a git tag. And remove this now. And of course, download only. Yeah, there you go. The range v3 CMake screws with the configuration options. Just like here, Vulk is screwing our beautiful system. So we gotta just download it and configure it ourselves, doing something like this basically. Yeah, so I'm just gonna say if Vulk added, so if the Vulk library has been successfully added as a package, we're gonna add a new library, which is an interface imported. We're telling CMake, we're just hitting it that we are importing this from outside. Target include directories, Vulk interface, and here there should be Vulk source there /include. And now in our case, Vulk doesn't have an include directory, I believe. Yeah, they're just in the top level directory, so we don't need this. And yeah, that's pretty much how you do it, I think. But of course, it also have a C file, so you gotta also make sure to say target sources, I believe, if I remember. And we're gonna go with Vulk private vulk.c. Well, of course, we gotta grab this guy, though I don't need this string, by the way. Just say this /vulk.c, I believe. And yeah, that's pretty much it, I guess. That should hopefully work out. Now it's configuring. I don't know how I can see the log of the configuring stage. I guess maybe it's right here, yeah. Alright, nice, lovely. May only set interface properties on the import target. Oh, I see. I see what's happening here. So just add a library, I think, called Vulk for now. And that library would include some directories publicly, and then it would target sources private. So instead of interface, I think, yeah, interesting. Okay, we're just making it like a static library kind of thing. Anyways, so go back to here and remove this Vulk now, and just put it like that. And what's the problem with CMake again? Missing variable is CMake C archive finish. What? This is kind of weird. I guess this is a problem of either IDE or CMake, not sure. Anyways, project. Oh yeah, I remember now. I think. Yeah. Yeah, it's my problem. So I think what's the problem here is that we're trying to basically build Vulkan.c, which is a C file, which requires a C compiler, but we didn't actually tell it here. Now we either have to add a C language, I guess, there, or maybe we could use this. Where is it? I've seen it somewhere here. Oh yeah, enable language, right? Enable language. There you go. And I guess you do it like that. Enable language C, I guess. And there you go. Now CMake is fine. Lovely. Okay, let's make sure that this gets built. And with that, let me also see if VMA got fixed with this. Okay, it seems to be exiting with code 0. Amazing. All right, let me try to see if that guy got fixed too. I don't remember what is it called. Oh yeah, hold on. Can I just link with Vulkan memory allocator like this, maybe? Nah, we still have that stupid thing. Ascend printf. Okay, let's see. It's not declared in this scope. You need to include a cdi.h. Weird. Why would I even need this? VMA allocator. Okay, what if I said then ascend printf or something like that? Sorry, stdio. Would that fix the problem of VMA malloc? Doesn't seem like. Pretty weird. I think it's I don't know, honestly. Okay. Otherwise, what if I added C here? Still have a problem. Stupid. I don't know. So stupid. I think they're not setting up their library right. Probably. At least for Linux though. Not sure. For Windows it worked for me just fine. I didn't have any of these problems. But anyways, who cares? Vk use platform XCB KHR and define Vk no prototypes. Nice. By the way, I'm defining this prototypes because, hold on a second. Let me make sure I'm doing it right. Yeah. So I don't have to basically include the function call since I'm not going to be using that. Or sorry, the function declarations, just the function types. Anyway, go back to main.cpp. How to do that? What is this? There you go. Okay. All right, let's go back to XCB stuff. Though for good to make sure we're handling exceptions right. And by exceptions, I mean, yeah, exception safety. I'm gonna also use another library, though, by the way, this would be, hopefully would be in C++ 26 or something, but it's basically unique nats, like, hold on, yeah, scope guard. Now there's a lot of implementations out there, but I like this one so far. It worked for me, and I'm gonna show you why I need this one. So although of course you don't have to use it, but yeah, you could just wrap all your stuff in classes or just ignore exception safety at all. That depends on you. But anyways, implementation of scope guards and unique resource as proposed in P0052. Okay, cool. So let's add this using CPM. Now this also needs an actual custom kind of build or something like that. Why? Because the CMake list that is inside of here just contains a test. It's just trying to test the thing, but in fact it's just header only kind of thing. So for header only libraries, what we gotta do something interesting here. So go back to here, and we're gonna do something similar to Vulk, pretty much. We're just gonna go with the name, which is a scope guard, and oopsies, and then alpha/scope guard, and the tag, well, 0.3.12. Since it starts with that V, I could use the version here instead of the tag. So yeah. Now, other than Vulk, we gotta say if scope-guard added, then we're pretty much gonna do something similar to that guy. Add library, scope-guard, and then target, and it's gonna be an interface in this case since we don't have any source files. It's gonna be an interface. So oopsies, target include directories, I think. Yes, and then scope-guard public. Actually, not public in this case. It's gonna be an interface in this case. Right. And we have /include. Okay, so we're gonna do something similar to this, but with scope guard instead. Cool. /include. There you go. And with that, I think we should have scope guard, and hopefully that's the last dependency that we need. So yeah, I don't know why it's highlighting that guy. Anyways, so now let's try to include it. There you go. Sorry, not SPD log. Scope guard, I think. Do I have to maybe build it first? Oh, I forgot to link it. Scope-guard, and there you go. I think now we're good to go, hopefully. Is it? Let me make sure. Hold on a second. Yep. Nice. Okay, let's see now. Include scope, and there you go. It just includes scope.h, and let's go. Nice, lovely. Other than that, let's see. All right, now here's the deal. We gotta say const auto scope, well, connection scope. And you gotta basically here, you gotta pass in a lambda or a function, whatever. Okay. I'm gonna pass in the by reference, who cares? And essentially, I'm gonna make sure to XCB disconnect connection. If you're coming from Zig, this is similar to defer, essentially. And there's also something similar to an error defer, though there is an in-used variable. This is always going to be in use, so can I do something like oopsies void connection scope. Oops, there you go. I'm just telling it that that guy is in used. Now there's also something similar to error defer in Zig. So basically what's happening here when you create oh, hold on a second, something is wrong here. Oh yeah, const std scope exit, sorry. Scope exit, I think. Oh, SR, it's in the namespace SR. So SR scope exit connection scope, it just have this guy here, XCB disconnect. If C is null, nothing is done. Though, look at this, closes the file descriptor and frees all memory associated with the connection. If C is null, nothing is done. And since if C is null, nothing is done, we could also do something else, which I believe is SR scope, no, unique resource. There's also another cool thing here, which is unique resource. And then I believe you could just pass in XCB disconnect function here, I guess. Let's see if that works. Definition. What's going on here? Oh, remove that auto. Okay. So it's a unique resource. We're connecting and then we're disconnecting at the same exact time. Amazing, lovely. Now here you just gotta say .get to get the raw pointer. Pretty cool, isn't it? Lovely. Now, whenever the function main would exit for whatever reason, if you exit from the function, it would go ahead and make sure to disconnect the connection, even if an exception happens, essentially. I see a lot of people getting this wrong, but yeah, anyways. So, what's happening here? .get 0. .get. Huh? What's the problem with that? No member named G. I'm not trying to access G though. That's weird. I guess let me try to restart Qt. Okay, how do you actually open the project? Projects? There you go, codeoxel. Let's go, nice. And hopefully right now it fixed itself. Okay, there you go, nice. It seems to be doing that. Alright, now. Very cool, very, very cool. Now, essentially we're just gonna say spd log error. Though we could get a logger. Hold on, how we do that? Well, let's see, const connection. Okay, let me get a logger here. spd log default logger. We're just getting the default logger for now, but what's nice about this is that we could easily change it to something else. Anyways, so logger.error, And here the format message of the error, XCB error. And we're just gonna say status. So here's status. Okay, cool. And also I'm going to actually make a little utility function here. And that utility function is XCB, error XCB. Okay, cool. And here give me the status. Though, is there maybe like an XCB error T or something? Nah, doesn't seem like. Anyways. Yeah, it just returns an error there. Cool. And I always just like to return an int. I'm going to show you why in a second. So I could just return exit status, exit failure. And here, of course, return exit success. And oh well, exit success. And before return exit failure, we're gonna log. Though we do need the logger now. So the logger is, let's see, SPD logger, I think. What this returns? Yeah, SPD log logger. Okay, cool. So SPD log logger, comma, int status. Let's go. And of course, this should be your pointer. We could go with another way, which is like we could create like a logger called XCB, for example, and just use that. Anyways, for now I think I'm just gonna go with this way of doing it. And now instead of having to do all this stuff, just return error XCB logger, comma, and then just pass in the status. And later on we could try to translate those statuses into actual error codes, I guess. Or anyways, error messages, I mean. No matching function for call to error XCB. Oh yeah, logger.get. Okay, cool. So now we should be able to basically connect with XCB successfully without any problems. Yeah, seems like, I guess, isn't it? Or is it still building? Yeah, it's executed with code 0, lovely. All right, what's next? Now we gotta actually, let's see. We got a connection. Now let's actually create an XCB, I believe XCB ID or something like that. Yeah, window T, actually, XCB window T, I remember. Actually, no, we gotta get the setup right. So XCB setup, well, const auto setup, and XCB get setup. You pass in the connection, and yeah, and use variable setup. Okay, cool. Now we have the setup, and basically that contains all sorts of cool stuff here. But anyways, now we're gonna create an iterator, a screen iterator, and that screen iterator is simply XCB dot. How do you do that? Oh, well, it's XCB screen, I guess, editor or something like that. I mean, I do have a project that I've done this before. Hold on a second. XCB code taco. Oh well. Let's go to my GitHub page then. Oh, I didn't log in yet. Interesting. Hold on a second. There is an easier way. Which is to simply, hold on a second. To simply look for XCB tutorial, and the first tutorial would be mine. Okay. And with that, let's go to the GitHub repo. And there you go. Lovely. And this is it. So we're gonna steal some code from here. Okay, XCB AUX get screen. Oh well, I used the AUX version. I don't want that. Let's look for the XCB tutorial though. Right. I don't want to use the AUX version library for now. Where's the tutorial here? Basic Windows on drawing, I think, if I remember. Oh yeah, there you go. So as you can see, XCB screen iterator, setup roots iterator. Setup roots iterator. Okay. XCB setup roots iterator, let's go. And here we got the setup. We need to give it the setup. And then it would give us an iterator, I think. Is it like this maybe? There you go. Okay. So now that we got the screen iterator, what we have to essentially do is while preferred screen number minus minus, we're gonna say XCB screen iterator, actually next, I believe next screen or something like that, I don't remember. Yeah, XCB screen next, and then you give it the screen iterator. Right. Actually, you give it an address, and this should probably not be const, since it's well mutated. Alright, pretty cool stuff, isn't it? Screen iterator, cool. So now this would basically call this XCB screen next, however much times. So if preferred screen number is, let's say 3, then this loop would work 3 times. It would call XCB screen next 3 times essentially. If it's 0, it wouldn't call it. Actually, nah, actually it would call call XCB screen next preferred screen number plus 1, since we're using the postfix instead of the prefix thing. So yeah, there you go. So that's pretty much it for that. Unless, of course, if you do need the preferred screen number later on, then you may want to keep it and just create a new variable. But right here, I'm just, you know, mutating that. Who cares? Okay, so now we should get the screen. So const auto screen is screen iterator dot data, and that should be it for the screen. Now that we have the screen, we could go ahead and create the window. And I'm not sure if I actually described this, but basically when your XCB connects here, I'm saying null ptr, which means I'm just saying to XCB to figure out the display name from the environment or whatever. Who cares? Like basically I don't care about which display you choose, and then here it gives me back the preferred screen number into a variable by a pointer, which is the preferred screen number or index. Okay, and then I'm just basically using it here with the iterator. So yeah, and of course this unique resource would make sure to call XCB disconnects on the connection that we got from here on the exit of this function, which is main in this case, or in case of an exception happening. which is pretty cool. This also makes sure that you don't have to every time, go down, to the end of the program and then call XCB disconnect, which you probably will forget. And if something wrong happens, like an exception, then you wouldn't call that and you would just leak the handle, which it doesn't really matter in a small application. But I just like to always have it ready for abstraction or whichever. Anyways, who cares? So after that, let's actually try to create a screen. Now, the first thing you do is you need to generate an ID for that. We need to create a window, right? You need to generate an ID for it. So here's how we can generate an ID. Let's see. So const auto window XCB generate ID, and then we pass in the connection row pointer. There you go. So that's the window. Nice. Next up we have okay, now we have to actually create the window, right? Though this just gives you an atom, so const auto window atom, if I remember well. So which you could use to get the reply. Anyways, so XCB create window, I think. Oh, what the? Why that guy is right there? All right. Anyways, never mind. So here, go with the connection. The depth is. Oh, what's happening here? Depth. I think there is like an XCB inherit from parents or something, or inherit, or I don't remember. Now let me see. Hold on. Where is that guy? Where is XCB? There you go. I don't know why I have this here. Okay, just put it there. And just put this guy here. Nice. Okay. Actually, I already done it. So here you go. Connection screen root depth. Okay, you get it from the screen. Screen. Next up, and I'm not getting autocomplete anymore. Or, I mean, well, that's stupid. Anyways, screen, create window. You give it the connection, first of all. Then you give it the depth, which is screen dot, well, root depth. And then you have the window ID that you have generated. And the parent. So the parent, just null PTR, I think. Actually, maybe 0 even. Yeah, well. Oh, sorry, the screen root. Okay. So basically, the screen is the parent of our top level window, I think. So the X, I don't care, but let's just go with 0. The width. Alright, let's go with 800, 600 for now. The border width, 0. Who cares about borders? Class, I don't remember. XCB window class. Come on, give me autocomplete. And I don't know why the autocomplete just spawns in the second screen. Okay, anyways. So class input output, make sure to do that, because there is another type of windows which are just input, for example, which are only made to not really output anything into the screen, just to capture input. I think, at least that's what I think it is, but I don't know. That's just a speculation, I guess. Visual. So the visual, I think we need to get it from the screen too. Root visual, there you go. And then the value mask. Now, if you don't know, while using XCB, we're actually using a socket. And and possibly that socket even in a network if the user is connecting through a network, although we're not going to care about that, but just keep in mind. So we have to basically, we have like requests and responses. Now there was xlib, which is the like XCB is supposed to supersede xlib. Why? Because, well, there's a lot of stupid stuff about xlib. For example, here when I'm going to say XCB creates atom, you know, or XCB connect, for example. I'm not sure though about XCB connect, but anyway, something like XCB create window, it would go ahead, send the request through the socket or whatever, but it wouldn't wait for the response. So while that's happening, it would just buffer in the requests and send them up when I tell it so. So it's kind of like the Vulkan command buffer. So we basically batch as much commands as possible and then send them at the same time, if that makes sense. But yeah, and then if you want to look up for the replies, you can do it later. But basically what's happening, just to keep it clear, in xlib, whenever you have a request, the next thing that you're gonna have is a reply, like immediately. You don't even have a choice. And then request, and again you have to wait for the reply. Request, then you have to wait for the reply, even though you don't really need the reply right now. But in XCB, you just send request, and then whenever you need like to actually send those requests, then you can tell XCB to flush. So it would go ahead and send those requests. It would send all of these at once. Or if you let's say we have request 1, 2, 3, 4, and then for example maybe you want the reply of the third request, let's say, then you would have to basically wait for the reply of the third request, which would basically kind of like flush all of this stuff, but maybe not request 4. Though this may be wrong in some details, I'm not sure, but yeah, this is the general idea of how XCB works, essentially. This is why it's better than xlib, though there's a lot of other things, but yeah, you got the point. Anyways, so value mask. Now here, which values we want to send. Let's go back to my example here. In this case, we're going to mask exposure. XCB event mask exposure. I don't know if I want that though. Hold on. Create window AUX. Oh, I see. So here it is. XCB CW event mask and CW back pixel. Yeah, exactly. Event mask and back pixel. Background pixel and then the event mask. Alright, now I could set the background of the XCB, but that doesn't really matter since we're going to render using Vulkan anyways. So yeah, I'm just gonna go with XCB CW event mask. That's the only thing I need currently. So you basically tell XCB which properties you want to actually send or you want to set beforehand, which in this case I only want to set the event mask. And now here you got a value list. So window, instead of value list, I'm just going to call it window attributes, you know. Const auto window at, well, not auto in this case. We're going to go with, I guess, XCB value list. Oh, actually it should be, yeah, my bad. It is just, I think, an array or something. Hold on. I forgot what it is. Hold on. Yeah, const void pointer. Okay, cool. It's const void pointer. Window attributes. So the window attributes, it's going to be, for now, let's just say XCB event mask exposure. Is it? Yeah, seems like. Yes. Alright, so that's nice. But for the window attributes, we are gonna actually send an address, I think. An used variable. Okay, so that's pretty much it. Now we could use this atom. Now, as you can see here, it's given us not the window, but an atom. So basically what we have done here, we're kind of like just generating some ID or a number, just reserving that to, well, in this case it doesn't even need to be a window, it can be anything really. Although honestly it would be nice to actually give it an explicit type here in this case. So XCB window T, though XCB window T is just a number at the end of the day, but just yeah, anyways, never mind. Alright, so now this window atom that we got from XCB create window, we could use it to wait for the response. Is like, did the window succeed creating or not? In this case, we're just not going to care about it for now. Though later on, if we want to check to make sure that it have been created successfully or whatever happens to it, then we could use that window atom. But anyways, here we're just telling it that, yeah, I want it in used. Alright, cool. So that should be good to go. I'm using here XCB ICCCM or whatever you want to call it. But for now, I'm gonna try to only depend on XCB, honestly, for now. Unless if I need to later on. Anyways, so XCB map window. Now, after we have created a window, supposedly, although at this point it probably didn't even create anything yet. We're just kind of like recording commands, essentially, that's gonna work out. But anyways. Oh my god, I don't know why it does that, stupid. Bro, come on. Give me some good intelligence. Come on. Anyways, never mind. Connection, and then you give it the window. Let's see. And if you want to be verbose, this is the window ID, not the window itself. Anyways, no matching function for call to XCB map window. Oh yeah, make sure to get the row pointer. And that's pretty much it. Window ID. Though, let's see how we can actually, hold on a second, let's see. Can I use unique resource in this case, maybe? Let's see. So it takes a connection and a window. Alright, I cannot use a unique resource in this case because it also takes a connection. So instead of unique resource, we're just going to go with the equivalent of zig defer, which is SR exit scope, I think. Or scope exit? Yeah, scope exit. Hopefully, I mean, there is a paper out there in the experimental. So hold on, XTD experimental. Scope guard or scope exit, yeah, scope exit. As you can see, it is already in the standard, but not all compilers use it, like implement it, because it's still experimental. It's still not officially added. So it's inside of the library fundamentals currently, TSV3. So hopefully they would add it to C++ soon, and at that point when they add it, I could just get rid of the library that I'm using currently and just use std instead of sr here, essentially, which is quite nice, lovely. And of course there's also, I think, a paper for unique resource. So yeah, pretty much pretty cool. All right, let's go back to work. Scope exit, well, it's gonna be called, I guess, the window scope. Okay, a lambda and capture by reference, and we're just gonna say XCB. Oh yeah, destroy. My brain have stopped for a second there. For a second. Gotta optimize my brain a bit. Alright. Oh yeah, window ID. Is that the way it is? But what happens if it's null, by the way? So it destroys the specified window and all of its sub-windows. Okay, cool. It doesn't say what happens if you call it on null. But anyway, that doesn't matter for now. Alright, cool. So XCB destroy window. Great, great, great. So essentially we're deferring this call of XCB destroy window to the end of the function, which is basically the end of the program in our case. Alright, lovely. So now after mapping the window, we should have a window, though let's just make a while true loop for now. Just so we can see it. Hopefully. Oh yeah, as you can see, nothing happened. Why? Because we didn't flush that stuff yet. We didn't flush the commands that we have recorded. Like map window and create window in this case would only work when we actually tell it to flush in this case. Okay, let's make sure to flush. And alright, what's happening? Weird. Oh, it crashed. Oh, there you go. There you go. We got a window. But it's still running, as you can see, even though we closed the window. So yeah, now let's actually correctly implement an event loop. So how are we gonna do that? Well, XCB set W name protocols. Alright, so here's the deal. I'm gonna say for boolean should close, and I'm basically initializing it to false in this case, since false is the default value, should close. And then if not should close, as long as should close is false, I'm gonna keep going. Okay, cool, lovely. Now what we're gonna say, so here it depends on our use case. Do we want to create a game which essentially runs 75 times a second or whatever, basically, kind of like, you know, or just runs every frame essentially? Or a GUI application which should only update when it needs to update. So what do you think? Should we go with the GUI application or a game? But anyway, for now we're just gonna go with the poll for event, which is basically, if you're making a game, then you gotta go with XCB poll for event. If you're going with like a GUI application that should only update when it needs to, a retained GUI application, then you gotta go with XCB wait for event. Though you could still interchangeably use them, though using XCB wait for event for a game, well, depends on the game. If the game only needs to update when the user like do something, like click a button or something, then yeah, I guess that could work. Although you won't have animations, I guess. But anyways, usually for games you won't like to go with XCB poll for event. But anyways, so how are we gonna do this? Well, alright, cool. So for XCB event, I believe. Is it? Oh, it's gotta be XCB generic event. Yeah, I'm using my own tutorial code. Interesting. event. I'm glad that I made that tutorial. Now I could actually use it since I forgot about most of this stuff. Anyways, so event T, generic event. Though this is a generic event, yeah. And essentially, you're gonna use XCB pull for event connection dot get. And let's make sure to add a semicolon there. Now this actually returns for me the generic event. And since that's the case, well, hold on a second. Actually, we need to do it. Well, in fact, yeah, just go with that. What's happening here? What's wrong? Weird. No viable overload. What do you even mean with that? XCB generic event. Oh, is it like a pointer? Maybe? Oh yeah, I see. I see what's happening here. But can I maybe use while? I'm not sure. Hold on. Well, not while, but basically kind of like this. Const auto, right? And then you'd essentially do generic event, right? Then you do something like this. I'm not sure if the while loop could do that. I think so, yeah, seems like. Alright, so now basically this XCB pull for event would give us an event, a generic event pointer, if there is an event to process. If there is no event, then it would return false. And so we're gonna exit this inner loop right here, basically. So this is essentially our application whole event loop, right? And this is our input event loop. So once we have processed all the events in the current frame, then we could possibly, for example, do rendering or updating the game, etc., whatever. So here, how I'm gonna process these events? Well, here we go. We got a process event function here. All right, so we got to switch on XCB event response type. And XCB event response type is just a macro, which I found interesting. I just found it through looking into the source code, though, as you can see, even in the official tutorial, they're not using that, I think, if I remember. Let me see. There you go. As you can see, they're using this kind of weird syntax, event response type, and they're doing this weird thing right here. I mean, we're gonna be doing the same thing, just using a readable macro that they already have, which is pretty cool. So switch XCB event response type. Right. Use of undeclared identifier. Interesting. Do I maybe need some other library or something? If that's the case, then that's a no-no for now, at least. I guess maybe I do need the util, a header of XCB, I guess. Let's see. Yeah, I guess so. No, actually it's inside of XCB event. There you go. As you can see, it's pretty much doing the same exact thing, which is pretty cool. Anyways, go back. Lovely. And now, yeah, I don't need the util. I just need event, XCB event.h. Though honestly, there's no need to like include another header just to get a little macro, honestly. For now, let's just avoid that and just go with that stupid way they're doing. Just hard coding it, right? Although it's not very readable. Anyways, generic event. There you go. So switch on the generic event. And if it's basically case XCB expose, then here we actually need to render when, well, in fact, you want to render here if you have a GUI application essentially. Because XCB expose basically get called when you need to actually update a portion or the whole screen. So yeah, pretty much. Though let me know if you want me to make a GUI application or a game. Anyways, so should close used in loop condition not modifying loop body. Alright, so now we don't have any events currently to handle, though right now we're gonna actually have one. But anyways, so for now, let's just try to run this. And there you go. Now we got a window which is properly pulling events. But as you can see, the window just contains garbage because we're not rendering anything. Though you could fix that if you basically OR this with an XCB CW backpixel, if I remember. Yeah. And then here in the window attributes, you add another attribute, though you gotta make sure the order is right. So let's see. Well, yeah, XCB backpixel comes first before, where is the other guy? Before event mask. So we should give that attribute first, essentially. So let's give it here. And I guess it's basically a hex value of RGBA, if I remember well. That's a lot of F's right there. 1, 2, 3, 4, 6, 7, 8. Basically, I think a 32-bit value. Okay, here I need to actually tell exactly what I'm talking about. Maybe in 32T, I'm not sure. Would that work out? Oh well, it's gotta be like equal to. Okay. No? Actually, no. Hold on. I guess it's like this. Right. Okay. Nice. Lovely. So yeah. Yeah. And you can see that we have a warning that variable should close used in a loop condition not modifying the loop body, which is right. That is correct, because we're never going to close from this while loop currently, because we have to handle something before we can do that. But that's very useful. And there you go. Right now we got a white background. Since we have used that back pixel. Though you could, for example, let's say make it blue, I guess, by doing something like, I don't quite remember, but in my code, I kind of have a self-documenting code if I remember well, unless if I change that. Let's see. Yeah, background pixel. There you go. So window background 2. Background color 2. Okay, that's the blue value, right? So the blue is the least significant bits. I guess this one's. I'm not sure where hex is supposed to be read from left to right or right to left. I don't remember. Anyways, let's see. Okay. Yes, yeah. So from left to right. Okay. So as you can see, we got yellow because this is like green is 255, blue 255, and alpha is 255. So if let's say we want to make it red, then we could do this. There you go, it's red now. But honestly, I don't really need to do any of that. Why? Too simply because I'm gonna be rendering using Vulkan later on, so why bother? And that may even make some problems for us, I'm not sure. So I'd rather not give it that anyways. But that was a good example, I think, if you want that. Alright, pretty cool. Now we just have this. Lovely. Now, I kind of glossed over some errors, which I don't want to handle for now. Well, what this returns a cookie. So this is also const auto window map cookie, you know. Okay, window map. I don't know if there's like a warning that would make sure that I don't avoid return values, like any return value. I think there is. I gotta check that. Hold on a second. Let's see. I'm not sure why my computer has suddenly become an airplane. But anyways, so new tab. All right, let's see. GCC warning return value or something like that. There you go. Let's see. No discard. Well, I cannot do that. There you go. W unused results. The not warn. Okay. So let's see. Is the relevant GCC option? It is turned on by default. Oh. Oh well. So only if the library actually makes sure to use that attribute, but well. There you go. This is how you need to do it, but I cannot do it in this case since it's not my code. All right. But how to force that on all functions? Yeah, there's no way. So yeah, I just gotta check the return types myself, seems like. All right, cool. XCB flush. So greater than 0 on success. Less than or equal to 0 otherwise. Great less than or equal to 0. So if XCB flush less than or equal to 0, then we gotta essentially, well, I guess let's do that little thing, const auto status. Though you'll notice that we do need the status again, so we could just do it this way. And let's go. Nice. Return XCB error. Oh well. Error XCB. Then we got the logger, and then we got the status. Oh yeah, well, logger.get, since it's a shared pointer. I think so, yeah, pretty much. Lovely. Yeah. Let me make sure that is fine. Yep, it seems to be fine. Otherwise, we can indeed use exceptions instead. Though, what do you think? Should we use exceptions instead? I mean, we could easily change that here. But anyway, it doesn't matter for now. Anyway, may change that later. Okay, so should close. Now we gotta handle the window closing, and for that it doesn't seem to be quite simple as just checking a close event. You gotta do some stuff. So basically closing the window is not part of XCB, or I guess even X11 itself, maybe. But basically you gotta use this XCB intern atom to get this window manager protocol's property. Okay, and then you just send this, basically sends a request, and then you could basically listen for the reply, and you would get the atom from that reply, and then of course you have to make sure to free that reply after you're done with it. And that's how you do it. Though I've done something, I mean it's correct, but it's not the way that XCB is to be used. So in this case, I just done atom then the reply directly. But what I should have optimally have done, if I knew XCB like fully, well not fully but at least I don't know, better than before, is that I should have sent all the atoms, and in fact not even just the atoms but everything else, until I really need the reply, which is in this case I only need it once I am near the event loop, before the event loop. And so yeah, and that's what I'm gonna correct right now, and you're gonna see how that works. So I'm just going to go ahead and copy this. Well, in fact, I don't know, let's just go with that anyways. All right, let's see how I can do this. Well, screen, window ID, attributes. Let's see. Though, well, hold on. No, actually, I forgot one little thing. I guess. Yeah. So we got the window manager property, which is actually being used here to set WM protocols. And then where's the other one? There you go. Window delete protocol, which is also right here. All right, interesting. So yeah, pretty much. Okay, nice. Gotcha. Okay, let's see how I can do this. Well, XCB flush. So before flushing everything, and in fact, maybe I don't even need XCB flush anymore. You know why? Because if I remember well, then pull for event already flushes everything. So let me see if I really need that. Let me run. I guess it's still building. Kind of weird. I guess it's running now. So yeah, it doesn't work that way for some reason. So anyways, let's, well, hold on. How do you oh, interesting. So my computer have became an airplane because I think I still had the debug build on. I guess, I'm not sure. Actually, let me see. Hold on. I'm not sure why my computer is going crazy. Hold on. Yeah, my CPU is going crazy. Who's hugging my CPU? Yeah, Qt creator. It's taking up 33.1% of my CPU time for some reason. I don't know why. Anyways, let's just run this in debug mode, and yeah, it seems like we need the flush though. I don't know. Yeah, I remember it's something like that, but it doesn't seem like that's the case. Let me try to run again. Try restarting it maybe. Yeah, the Qt creator for some reason is going crazy with my CPU. Codoxel is still running, yes. Bruh. Why ask me like 3 times or something? Anyways, so I have Qt creator here. Nice, lovely. Codoxel. By the way, did you guys understand how XCB works so far? It's pretty interesting, though. Once, like, at the start, especially that there's no, well, not no, but there's little documentation, little tutorials. It's quite interesting. Like, it does things a little bit differently, so it's a little hard to get it right at the first time. But yeah, with time, I think, and a little bit of practice, I kind of got the general view of how XCB works. But yeah, anyways, though still not fully, of course, that's for sure. It's pretty huge API. But anyways, so now let's actually continue what we were doing. So before the flush, as I said, let's send the requests to the window manager to give us the close atom, so we could actually check for that. That's basically what we're gonna do right now. So const auto window manager, what is it called? Protocols property. So first of all, we need to get the protocols property. And to get that, we're gonna use XCB intern atom to send a request to get that atom. So connection.get comma, only if it exists. I don't know about that, just say true. And then the name length. Now the name length is essentially okay, 16. Though I could do something pretty cool here, which is, I guess we could have like a const expr, I guess, or whatever, and have, well, what I'm doing here, no, not here, I meant here, name. That's a pretty long name right there, and it's basically WM protocols. Now what I could do, though I'm not sure if I really need const expert now, let's just go with const, who cares. And here I guess we're gonna go with the length, right, or size, or what? Oh, I think I have to go with size of, but yo, just say const std string view. Okay, and then we could just say dot size. Okay, cool. That's the length. The name is window manager protocol blah 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 blah. Well, in fact, oh my god, just copy this guy. Do you have any idea on how to fix that? The autocomplete thing just jumps to my second monitor for whatever reason, which is very weird. Anyways, I guess I need to give an address maybe, or actually maybe dot data. Yeah, dot data seems like. And oh, UN16 name length. I guess I should probably cast this. Static cast. Uint. Here I'm basically telling C++ that, yeah, I'm aware that this could fail. Don't know if I can help with that. I only have one monitor. Yeah, I see. So basically, what's happening here? I don't get it. Oh yeah, unused variable, never mind. So essentially what's happening here is that XCB intern atom length is uint16t, but then the string view's length or size is actually size t. So I gotta tell the compiler that yes, I do want to narrow cast to uint16t. And in fact, static cast, it's called like this ugly name and this ugly syntax, just to make sure that the actual writer, or like whoever is reading the code, is well aware that this is right here. So ugly code is very visible. Anyways, unused variable property. Well, actually, this is the property atom. It's not the actual property, but anyways. So name. Atom, pretty cool. Now we're pretty much just gonna go ahead and do the same with WM delete window, I think. So const std string view. Well, honestly, just copy this guy. right? And then window manager delete window protocol. So window manager. There you go. It is WM protocols. All right, lovely. WM protocols. Okay, cool. Now let's actually go ahead and do another atom. And that atom would be, let's see. Oh, we just got to change that guy to delete window protocol. So window manager, delete window protocol atom, XCB intern atom. Then essentially change this to the right guy. Oh, there you go, and there you go. Very nice. Oh, I forgot to actually change the name of this guy. WM delete window. And there you go, lovely. And that's essentially it for the atoms. Now, I'm not gonna get the replies immediately. I'm not gonna tell it to get the replies immediately. In fact, I can probably do that already since it's the last thing that I'm doing anyways. Yeah, pretty much. But at least these two guys would be sent at once instead of one by one. So that's nice. Lovely. And maybe after I request the replies, I wouldn't need to even flush. So let's find out. Let's find out. Now let's actually get our replies. How do you do that? Well, you pass in the connection, the atom, and null. I think null is basically for errors. We could use that later on. Anyways. All right, cool. Status. Okay, let's see how we can do this. So, const auto, well, window manager. Oh, what do you mean by atom? No, this is actually not the atom. This is the request. Yeah, this is the request. And same thing with this guy. That's the request. Okay, cool. So this guy, instead of request, by the way, I don't know why I have this on my head this whole time. Anyways, so instead of request now, we gotta go with reply. Yes, reply. Now XCB, what is it called again? XCB intern atom reply. Okay. Connection dot get, and then the cookie, which, oh well, it's actually, they call it cookie. Yeah, my bad. All right. Well, that makes sense, because the cookie essentially is what you use to identify the request. Yeah, because this is not the actual request. Anyways, okay, cool. All right, now the cookie. Well, let's start with this guy. And then XCB generic error. Just gotta go with null PTR for now, though maybe later on. It seems to be an array of errors, so maybe we're gonna get all the errors that happened before requesting this reply, or essentially before flushing, maybe. Not sure. But yeah, I guess. All right, pretty cool stuff. So now we got this reply. Now we're pretty much gonna do the same exact thing, though maybe I would like to essentially put this request in like some sort of array later on. But anyway, for now, just gonna hard code stuff. Cookie reply. All right, so now I'm just gonna change the name to delete window protocol. And there you go. Though make sure to change it here too. Yeah, I do remember this actually caused for me a problem since I forgot to change something. Hopefully I won't get that anymore. But I don't think that would happen because I have these warnings on my face every time that this is in use. So if I accidentally don't do that, it would tell me that this is in use, and I know for sure that something is wrong. Anyways, other than this, reply. Now we could actually collect our atoms, essentially. So const auto. Basically, const auto should be your default. Now in C++, by default, everything is mutable. For Rust, in Rust, for example, or Zig, I think. No, I'm not sure honestly about Zig, but anyway, for Rust at least. I mean, I don't remember about Zig, but for Rust at least, everything is immutable by default. So basically, everything is constant by default. In C++, everything is mutable by default. So basically, C++ is by default will shoot you in the foot by default. So just try to get into the habit of using const everywhere as the default thing. Now the thing is, while Rust got the chance to basically start from scratch, and do the decisions right, C++ is like, needs backwards compatibility. So that is why the language have become so verbose to just do the stuff that you think should be the default at this point in 2023, but it isn't, because of backwards compatibility and the fact that C code should work on C++ too. But yeah, anyways, who cares? But later on, maybe Zig would take over. I don't know. We'll see. Anyways, so reply. Instead of reply, now we're just gonna take the atom, and the atom would be the reply. So protocols reply dot atom. Okay, but then of course make sure to actually free that atom. Now to actually free that guy, we gotta make sure to use the free function of C. And now to do that, well, I think I have a better idea. Now the thing is, we could use here a unique PTR maybe, or a unique resource, either one. I think, well, let's see if unique PTR would work for us in this case, though I don't think it would, honestly. I don't think it would, but let's just try it out. I'm not sure. I'm still shaky when it comes to smart pointers in C++. I have to research about that more. Anyways, so here unique PTR, and well, I don't really need to give it the templates. And here XCB intern atom. Now hopefully it would take also a destructor, which is free in this case. Yeah, it doesn't work out that way. It doesn't deduce, though I could indeed go ahead and tell it explicitly in the template what I want, but why? Just use unique resource, and that should work out. SR, of course. And yeah, look at that, it just works. So you just give it the thing that you're talking about, and then the function that you're talking about, and it would deduce the templates. Not sure why that's not true with unique PTR. And of course, if you call free with a null PTR, I think it's fine. So even if this fails, it is still fine to work on, to use free. So if it is not fine, we cannot use a unique resource. So we either gotta use scope exit or make our own wrapper around resource or something. Anyways, who cares? Okay, cool. Now we're pretty much gonna do the same exact thing. Now instead of changing this to fit my needs, I'm just gonna do it. Copy this guy again and just change the names. So manager delete. Well, delete window protocol. Let's go. Yes. Now here, window manager, delete window per cookie. And there you go. That's what I'm talking about. All right, lovely. So you got two unique resources which gonna free themselves after they're done. Cool. All right, pretty cool. Now let's actually grab this guy. Const auto window manager. Property atom. Cool. Now we're pretty much gonna do the same thing with the other guy. We gotta extract the atoms. So window manager, delete window protocol atom, and we gotta go with delete window protocol reply atom, and there you go. That's what I'm talking about. Now we actually got the atoms, which is quite nice, hopefully. So if I actually run this, let's see what's gonna happen. Would it even work? Yes, it does indeed work, which is nice. I mean, the program works. Now, can I actually get rid of the flush right now, since I'm actually waiting for those guys? That's what I wonder about. Yes, as you can see right now, when we actually waited for the replies, there you go. That's what we get. Lovely, isn't it? Pretty cool. Lovely. All right. Nice. So I don't need the flush anymore, since I'm waiting for the reply of these atoms, and with that it would basically flush everything implicitly, everything that comes before it implicitly. All right, lovely. And now we don't even need the flush that I had to do here. Cool. Nice. Now what's next? Okay, so now that I got the atom, so now I got a way to actually identify that that property and that delete window protocol thing. Though I almost forgot one thing, which is the fact that I need to actually set a property on the window. For whichever reason, I need to set WM protocols. All right, let's see. XCB, I don't remember. Now here I'm using ICCM, which is much more readable, and it really helps. But I'd like to, as much as possible, to avoid pulling in another system library for now, if possible. So XCB, I mean, those other libraries are just basically made on top of XCB though. Right, what I want, XCB property, I think, set window property maybe, or something, or maybe set, I don't know, property. I really don't remember. Okay, let's see. I think if I go back to their tutorial, if I remember, there was something like that they have done. Okay, let's go back to, or maybe let's see, hold on. No, it doesn't seem like. Tutorial. Maybe this guy. There you go, XCB change property. I cannot believe I forgot about that. All right, cool. So I think this is probably what I need in this case. Okay, so here we gotta get the connection. Oopsies. Connection.get, and then the mode. The mode in this case would be replace, since we're gonna replace this the property, I think. And then the window ID, and then the XCB atom T property. By the way, why do we even use properties? Can't we just tell it to like just give the string directly? But now remember that we're using socket. It's kind of like networking, you know. So, and just you need to realize how much bytes you need to send through the network or through the socket to actually keep on sending strings. So that's why this is a little optimization essentially, to just kind of like, even in Windows I think that's a thing, I'm not sure, but basically you just tell the server about your string, and then it gives you back an atom or just a number or an ID that identifies that resource. In this case, the resource is the string that you have sent. And then later on, when you want to talk with the server, you just tell it, instead of telling it the actual string or resource or whatever, you just give it the ID that the server gave you. And the server would understand that you're talking about that resource. So that's how it basically works. Hopefully that makes sense. Let me know if that makes sense. Okay. So property. Now in this case, the property is this guy. Well, in fact, this guy. So I'm just gonna give it that. And the type, not sure about the type though. Right. I think it's, let me just see some example. Yeah, XCB atom string, I guess. Or atom property, I'm not sure. Or window. I don't know. I really don't know. I think it's a string I can name. Well, let's just try string. And the format, no idea. I guess let's just go with 8 for now. I guess that's how much bits. And the data len. The data len. What are you talking about? Oh, well, that's not gonna work out. Well, actually we have an atom. Hold on. So XCB atom, let's see what are the stuff that we could actually use. Yeah, it's an atom. It should be an atom, right? My bad. Because we're giving it an atom, not a string. And then the format, I don't know. What is the format in this case? Well, no idea. XCB atom. Let's see if I can find something about that here. Alright. XCB atom format. Oh, as a list of 8-bit, 16-bit, or 32-bit quantities. Now, I think atoms are UN32, right? And by the way, it is yeah, 8, 6, so bits. All right, cool. So atoms, what are atoms? Hold on. For example, this XCB map window gives us a cookie, right? And now what is that cookie? Huh? Hold on. XCB window T, what it is? I don't know, hold on. I like this feature of going back. Anyways. Where's the window T? There you go. And yeah, it's UN32T. Let's go. So it's 32 bits. An atom is 32-bit, just like Vulkan uses UN32. Oh my god, UN32T for everything. Anyways, right. So I think I probably have to use U32 for that, for the format. The length, though, it would probably be 1. I don't have I don't have an array in this case. Though that's interesting. Can I like get multiple atoms at once or something? Or change multiple atoms at once? Or whichever. I mean, to find out, let me try to get the definition of this guy. Hold on. And let's see if it's a bit field or not. It's not. Yeah, it's not. Doesn't seem like it. Yes, doesn't seem like it. So I don't think that would work out, isn't it? Unless if I'm not understanding something here. I don't know. Let's not overthink it for now. Let's just go with the data. And here I need to give it a reference to that data. In this case, the data is, well, the window manager protocols property atom, I think. Oh, nah, it's the actual value, which is in this case maybe delete window protocol. Yeah, I guess so. Okay, let's try to see what we have done so far. So basically, we're replacing, and the property is this guy, the manager protocols property. We're replacing it with an atom that is delete window protocol. I'm not sure if that makes sense, honestly. But we'll just have to find out, really. We'll just have to find out. Though, let me see, does this return an atom? Yes, it does. So I have to flush. Yeah, I have to flush. Change property. Okay, well, I gotta do that again. Anyways, const auto status XCB flush connection dot get. Alrighty, then status less than 0 or what exactly? XCB flush greater than 0 on success or less than or equal to 0 on failure. And in that case, we're just going to return right, what is it called? Error, I think. XCB, there you go. Give it the logger, and then finally give it the status. Nice, nice, nice. And yeah, that should work out, hopefully. Of course, nothing yet, but yeah, it just compiles. Nice, 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 nice. Now we gotta actually check for that event here after we kind of registered it, hopefully. So let's see. So if I remember, by the way, why this stupid thing is still here? Oh my god. I don't know how to even close that. Task manager. Yeah, I don't know how to close that window. Anyways, case. So case, XCB, I guess event. Client event. Client message, is it? I don't remember. Let me see. Let me go back to my code. To my old code. Where is it? Here you go. Okay. So here's the deal. Yeah, client message. Right. Okay, cool. Honestly, okay, cool. And I just gotta basically cast that generic event to a client message, and then I could get that guy. Cool. Now if, well, in fact, let me, since I'm gonna declare a variable here, I need the block break, not a Minecraft block though. Okay, XCB client message, and then I'm gonna say const auto client message, and it would be actually, I guess it's reinterpret cast, probably not static cast in this case. I'm not sure. Let's see. Let's just use static cast until it doesn't work, then we're gonna switch it up. And in fact here it should be XCB client event client message, seems like. Yeah, as you can see, you need a reinterpret cast in this case. And there you go. Nice. Now we got the actual client message from that. So basically, in some sense, the generic event is like polymorphic, but not in the C++ OOP way, but in C, in the C way. So in the C way, you just, you know, cast pointers from something to other thing. But yeah, anyways. Right. Now, if client message event data is that guy. Okay. Let's see if client message data, and I think data is probably a union between data 16, data 32, data 8. In this case, we're gonna go with data 32. It depends on the client message basically, and we gotta look at the zeros. Now, how you access this data is actually, yeah, it's fine. Never mind. It basically depends on that particular thing, that particular client message. But anyways, in the case of this guy, you gotta check if it's the window delete protocol atom. So as you can see, we're using this atom to identify. So again, to just reiterate, when you have like a string and then you kind of like basically like an atom is essentially an ID that you agree with the server that this ID refers to this resource. Okay, well, anyways, all right, nice. Now what's next? Now if that's the case, then we can indeed get the timestamp if we want to, which is the second value in this array. Otherwise, it doesn't matter. So I don't care about the timestamp for now. So for now, I'm just going to say should close is equal to true. And finally, we got rid of that stupid warning. Though we don't need a block in this case. Just say should close equal to true. And yeah, lovely. Where's my Clang format, by the way? Weird, isn't it? Bruh. I don't know where my Clang format have teleported. Anyways, let's try now and see if this actually works. Oh, why it's called 2? Really? I think it doesn't, isn't it? Or maybe it does. What? I don't know. Okay, let's see if it really pauses. Yes, it does. Interesting. Cool. So I think I've made it. Let me just make sure again. So right now, if I actually try to close this, and as you can see right now, it doesn't even close at this point. Why? Because he sets it that property. Once you set that property, the window wouldn't even close until you tell it to. So yeah, pretty much that's how it works. So yeah, we have done it pretty much. We have done it. Lovely. Value stored to client message during its initialization is never read. Okay, there you go. Pretty cool. So that's essentially it. Now we got a beautiful window. All right, it took around, well, 94 lines of code, kind of. Anyways, so what's next? What's next? What's next? Let's see. Well, I think right now we can start Vulkan already. Though, hold on a second. All right, never mind. Okay, cool. So now that we got this out of the way, let's see what we can do next. Window managers, protocols, property, cookie. Now, can I somehow in XCB tell the events to like being sent, but at the same time I'm doing something? So like asynchronously, essentially. Yeah, not sure about that. I mean, I remember there's some other function other than XCB flush. Hold on. No, there seems to be one flush. What else? Yeah, there doesn't seem to be another. Though I remember, oh, I guess it's sync. I guess it's called sync. XCB sync or something like that. I don't know. Go back to the documentation that we had earlier. Well, it cannot. Let's see if there is a sync function. There is not. Interesting. Yeah, I don't know. Weird. Anyways, who cares? Now let's actually try to, I guess, load in the Vulkan functions, global functions, and then create an instance and then create a surface, essentially. So how are we going to deal with that? Well. XCB, change property. This gives us an atom, by the way. Oh well. I don't know what to call this one. I guess change property atom. I don't know. Anyways. Okay. Now I'm just thinking where I want exactly to load in Vulkan before the screen, before the thing, before the window I mean, or what exactly. Yeah, I guess you know what I'm gonna do before flushing maybe. Why not? Okay. So let's actually go ahead and say, first of all, we need to load Vulk, okay? Vulk initialize. Now we could go ahead, since we're just using XCB only, we could do it ourselves. Otherwise, we could depend on Vulk to do it for us. Now, if you say Vulk initialize, what it's going to do basically, if Windows 32, then it's going to do that stuff. Otherwise, in my case, it's going to go ahead and try to load it from libvulkan.so or libvulkan.so.1 or libvulkan.so, basically. Right, and it's actually using RTLD now, which is not the most optimal in my case, I guess. I don't even know why it's using RTLD local. Yeah, RTLD local is 0, as you can see here, and so it's just useless. This is just for compatibility, so I'd rather do it on my own. Especially that we don't care about cross-platform here, so yeah. Okay, so here's the deal. I'm just gonna do something like this for now, and go back. And this is also nice to show you what's really going on in the background. We're essentially loading the Vulkan library dynamically. So, and instead of RTLD now, since I just need some, just a few, if not just one function, then why, load everything, all the symbols now? So, and local, as I said, is just for compatibility. For backwards compatibility, so it's just set to 0 basically. So this is useless. And RTLD now, I don't want that, since I don't want to load all the symbols now. I just want to make it lazy. So I don't remember which header I need to do that actually. Hold on. I think it's DLVCN or something like that. It's weird names. It's always weird names. Dynamic link, there you go. I think that's pretty much it. And as you can see, relocations are performed at an implementation, well, what? Implementation dependent time. Relocations, what exactly is a relocation? Let's see, relocation. I don't know what's that. Anyways, who cares? So I'm just gonna go with RTLD lazy, and I need the DLFSCN, I think, or anyways, whichever. Though, by the way, we could get rid of Vulk. We could do it manually if we want to, but I'm not really sure if I really would like to do that. I don't know if I want to get rid of Vulk entirely even. Anyways, I don't know. We'll see. Alright, well. Include what? DLFCN for RTLD lazy and for DL open. Well, just, DL open. But anyways, who cares? Just do it like that, okay? So now, as you can see, I have that available, which is nice. So module, if not module, then do that. And if not module, return vacate error. Well, initialization failed. Now, how do you actually check the error of DL open? I think by checking error no, maybe? Okay, return value. If file cannot be found, cannot be opened for reading, if not an appropriate object format file. Processing by DL open. During the process of loading file, relocating symbol. DL, okay. Of loading file or relocating its symbolic references, DL open will return null. Will return null. Okay. By the way, RTLD lazy.
Yeah, so the only catch that I forgot about between, what are your thoughts on Qt Creator so far? It's pretty decent. At least it's faster than VS Code. So, but it's pretty decent so far. It's pretty cool so far. There's some minor nitpicks, like my tooltips being in my second screen. But yeah, other than that, it's not bad so far. It's pretty cool. Okay. Okay, so as I said, there is something that I forgot about RTLD lazy and RTLD now. So at least from what I understood, RTLD lazy won't perform these relocations. I'm not sure exactly what they mean by relocations, but I would think that it's possibly basically kind of like loading the symbols. Relocation. Well, let me see if I can find something about it. Linux relocations. Do you like XCB so far, Marty? Relocation is the process of connecting symbolic references with symbolic definitions. Okay, so it seems like relocation is the process of connecting symbolic references with symbolic definitions. Pretty descriptive. Okay, so when a program calls a function, yeah, pretty much, yeah, it's kind of similar to essentially just loading a symbol. So basically, using RTLD now in this case, what's going to happen is that if you use RTLD now, it would go ahead and load all the symbols that inside of the Vulkan library. Now the problem with that is that we only need to load one single symbol from the library. So why use RTLD now? Though the only problem with that, or the catch actually, not the problem, but the catch, is the fact that you have every time you actually, like when you use RTLD now, whenever you use DLSym to get a symbols, you don't need to check for errors. You don't need to check if that symbol that you got is valid or not. But using using RTLD lazy, yes, it wouldn't load all the symbols. It wouldn't load any symbols, hopefully, when you say DL open. But whenever you use DLSym, you have to check if it's null or not, if it succeeded in getting that reference or not. Though that could also be used for something pretty interesting, which is, for example, let's say you don't know if some symbol is inside of... that's bad. Anyway, never mind. I mean, it's nice personally to use STL unless I want to send fake input to some other window. Yeah, xlib. I don't think that's a problem with the XCB, though. I'm not sure. Maybe that is a problem with XCB, but well, at least Wayland that's not a problem there. But yeah, anyways, I did indeed try Wayland too, but I didn't really get so deep into it yet. But anyways, all right, never mind. So there's also DL close, and there is... Now I wonder if DL close can accept null or not. Okay, let's go back to the documentation here. Okay, there you go. So if an error occurs during the process line of file, we'll return null. Through DL, okay, I can call DL error to know exactly what happened with my with my loading instead of relying on Vulk, which would just tell me, you know, initialization failed. I don't know. I don't care. There's similar things for Wayland 2. Nothing can stop my macros. Alright. DL error. Pretty interesting stuff, isn't it? If successful, returns a null terminated character string, otherwise null is returned. Ooh, I see. I see. So, okay, cool. Cool. Honestly, I would just get rid of Vulk, I guess, and just do it manually myself. I don't know, we'll see. Anyways, who cares? If not module, though, I wonder if DL close can be called on null. Hold on a second, DL close. It's not saying anything about null though. Ooh, there's some interesting information here. Though it's really not saying if you can actually call it on null. Though we could try and see what happens. Alright. So let's try to do something interesting here. What happens if I call DL close on null PTR? Ooh, okay. Null pass to a callee that requires a null argument. But how did he know that it can? Non-null. Okay, let's go. Okay. In map and close, a shared object opened by DL open cannot be used again after calling DL close. As you can see, it's telling it non-null, which tells me that you cannot call it on null. Okay, interesting. Pretty cool. Lovely. Love that. Nice. Okay, so I cannot use a unique resource, since it would, if it doesn't work out, it would call it on. Though, I mean, I could use it, but it's more problems than it's worth, I guess. I don't know. DL close. Let's see. Right. Unique resource. So let me see what happened in here. This is super weird. This is the move. Reset. I don't know, honestly. Anyway, who cares? I think I'm just not gonna use it, maybe. It's very hard to choose. Anyways, const auto sr unique resource. Let's try it out, I guess. Or honestly, let me see what's gonna happen if I DL close on null PTR anyways. I wonder if I'm gonna get a segmentation fault or something like that. There you go, I got a segmentation fault. Interesting. So that's nice. So I can actually go ahead and check out what's happening. All right. How can I actually, there you go, stop the debugger. And let's go back. Okay, so here's the deal. It's fine. Just use a unique resource and let's see how we can do that. So module is DL open lib Vulkan RTLD lazy blah 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 blah. Okay. No viable. Oh yeah. And it's basically DL close. Okay. Now the thing is, we gotta check if this is null or not. So if it is null, if not module dot get then essentially we have to try to maybe reset or release. Basically what I really want here is release. Basically I'm telling it that you don't own that module anymore, so we wouldn't call the destructor on it. And then I could say module.reset, I guess. And it should reset on the second guy here. That's essentially what I'm looking for. Module.release.reset. Though I'm not sure if reset would just do the release for me. Or hold on. It's weird. Right. Where's the operator equal? Oh, it's actually deleted. Okay. And when you give it that guy, it actually goes ahead and resets. Unless if you say release. Okay. So you do need to say released first, then say reset. Alright, pretty cool. So now I need to basically do something similar again. I probably need to make a wrapper for this, honestly. So if not module dot get once again, then module dot reset that guy. Now if not module dot get module dot release again, though actually here, then again release the resource, and this time we just gotta say let's see, we just gotta use DL open to get a message to log essentially. So logger, I guess, error, and then I would just say failed to load Vulkan library. And then here I could say this and then say DL error, which would give me the actual a more descriptive message, hopefully, of what really happened wrong there. So yeah, let's see what's gonna happen now. I guess it was fine, right? But what happens if I made the, let's say, the library name wrong? Yeah, it doesn't seem to me. Well, what if this is also wrong? There you go. As you can see, error, failed to load Vulkan library. libvulka.so cannot open shared object file. No such file or directory. There you go. There you go. You get a much nicer error. Though honestly, there's no need to say failed to load Vulkan library, I guess. Yeah. It's pretty clear what's happening just from the error that they give, honestly. So that's nice. Though you may want to say DL error here directly, but that is very dangerous. You never want to do that. Never pass a dynamic string or basically a string that you're getting from somewhere else as a format. That's a good security weakness. But anyways, Marty Flowers back. Welcome back. Alright, so logger error and then DL error. Now it's basically would be like this. When the library is not be able to be loaded, it would say cannot open shared object file, no such file or directory. Lovely. Okay, cool. Though, by the way, I could make my own class right now to do that for me, but I just don't want to do that now anyways. So yeah, that's pretty much it. Though, what happens if the first one is wrong, but the second one is possibly right? I'm not sure which one is being used by Vulkan to load. Yeah, as you can see, it's fine now, since the second one actually was successful in my machine. So yeah, okay, cool. So how to actually stop this guy? Amazing. All right, so logger error, DL error, and then return error failure. Exit failure. Right. So that's basically it. So I wonder if we could do the same with the window. No, yeah, I said we cannot because it needs the connection. Yeah, I just remembered. Okay, cool. So we need a custom class for that or something. Anyways, if you want to do it that way. All right, cool. So this is fine now. Now, okay, what I could do is const auto, right? And then say here vk get instance proc addr, and then essentially say dl. How do you actually load that guy? Yeah, dl sym. And then here you give it the handle, which is our module .git, and then you give it the name, which is vk get instance proc addr. Right? Cool. That's basically how it goes. So I'm trying basically to load from the library this function, and this is the only function that I actually need from the actual library. That's why I'm using RTLD lazy. Why load all Vulkan functions just to get one? Anyway, but since I'm using RTLD lazy, I gotta make sure that it is not null, that it indeed successfully have been loaded. Okay, so here's how we're gonna do that. Well, I guess if that's the case, well, in fact, I may need that function later on, isn't it? I don't know. Now we have two ways of doing this. Either we can do it manually, you know, and get rid of Vulk, or we could use Vulk with Vulk initialize custom. And you just pass in get instance proc addr. But hold on a second, I need to check out on something, because we're doing things a bit differently here. No function, no matching function for call to Vulk initialize custom. What? Didn't I load Vulk? What the? Okay, cannot convert arguments of complete type void const. What the? Hold on. Vulkan initialize custom. It needs pfn vk get instance proc addr. Oh yeah, I see what's happening here. I need to reinterpret this. Reinterpret cast. Right, and this is gonna be pfn vk get instance proc addr. And there you go. But hold on, before we do that, let me see what's happening here. First, it's actually setting it globally, and then it's saying Vulkan loader. vk create instance Lloyd. All right, Lloyd what? Where is the Lloyd function? Oh yeah, okay, I see what's happening. But does it check for errors? No, it doesn't. Lloyd. What? It doesn't check for errors or what? Or maybe it's expecting me to check for errors. Huh. Da, 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 da. Honestly, I think I'm just gonna do it manually anyways. Who cares? Right. So we could get, with that, we could get rid of Vulk completely. What do you think? Should we still use Vulk? Or just roll it on our own anyways? Avoid one other dependency and make sure everything is correct. And third of all, you don't use global state. And you can indeed make multiple instances, I guess. I don't know. Anyways, so I guess we could try. Oh, what the? Why removing Vulk? Huh? Removing Vulk for some reason made XCB connects error. What the? Oh, because I didn't include Vulkan, I guess. Yes, I think so. Oh, but hold on. Oh, I see now. I see. The thing is basically Vulk was including Vulkan, and Vulkan, because of VKU's platform XCB, was including XCB. But honestly, just to not rely on such weird implicit behavior, let's just say xcb.h. Why not? Explicitly. And yeah, that's pretty much it. Now we don't need Vulk. We gotta roll it on our own. Which is gonna be very tedious, honestly. But anyway, who cares? Okay, well, we could get rid of this package. And get rid of this guy. One less dependency down. We don't necessarily need SPD log, honestly. It's just nice to have. But you know, I'm just gonna keep it. It's pretty cool. Vulkan memory allocator, same thing. We don't really need it, but it's the most performance. I don't think we could do better than that. And Vulkan headers, we do require that, unless if you want to rely on the system. Scope guard, we could indeed go ahead and make it ourselves, but I'm not very confident on my class making stuff. But anyways. So for now, yeah, we could like replace it later on with our own implementation, etc. Anyways, who cares? So right now, go back to CMake. Let's make sure I'm not linking Vulk or whatever. And there you go. Now we got rid of one dependency. But now we gotta do that stuff ourselves. Now, honestly, currently I only need vk create instance, and this is what's nice also about doing it yourself, is that you can basically, now Vulk would load basically everything, all the functions that it can load. But in my case, I can, since I'm doing it on my own, I can load just the function that I really actually going to use, basically. So yeah, so const auto vk get instance proc addr. Well, actually, let's just do it here, I guess. Const auto vk get instance proc addr. And now I could actually go ahead and use that. So vk create instance to get the vk create instance function. And now instead of loading stuff from the library, which I actually shouldn't do in this case, I could just use now vk get instance proc addr. Now I do need to reinterpret this thing. So reinterpret cast to pfn vk get instance proc addr. Let's go. I guess I did something wrong. Yeah, I just need this guy. And there you go. Lovely. Lovely, lovely, lovely. Now I get my autocomplete stuff. So here we gotta need the instance, which to get global Vulkan functions, you just need null ptr, and then you need the name, which is in our case it's vk create instance. Essentially. What expected at the end of the declaration? Oh, well. Alrighty, but what's going on? What's the problem with this? Oh yeah, need the semicolon there. And used variable vk create instance. Okay, pretty cool. So as you can see right now, we just got the instance proc addr from the library. And then we use that vk create instance to essentially load the global function vk create instance. Now we could go ahead and use that up. vk create instance. What's going on? Oh yeah, I have to actually cast that stupid thing again. Interpret cast. pfn, though I could probably make some helper function for this stuff. vk create instance, because basically what's happening here is that vk get instance proc addr actually gives you a void pointer, because it doesn't itself know the actual type of the function. You are the person who knows, so you have to cast it to whatever type you think fits, which is in this case of course this pointer function type of create instance. Anyways, so now we need the create info info of the instance, and we need the allocation callbacks, and we need the instance. Alright, so here's how I like to do it. vk instance, and then put these in a block. Oops. Just like that. But of course I'm gonna make sure that vk instance is outside of that block, since I want it visible afterwards. Now basically I need vk instance. Well, what's the problem? Oops. Why it's not oh well, I guess let's remove this for now. It's really ruining my okay. So vk instance create info, there you go, and the create info, and of course this could be const, so const, and then the create info dot. And now I only need the extensions, I believe, and of course I'd like to go with the application info too though. So application info, and for the application info, vk instance application. Ooh, hold on a second. Okay, vk instance. Yeah, oh my god, hold on. Don't know why that kills my. Oh well, I actually need. There you go. Cool. So yeah, that's actually application info though. There you go. XCB. Oh, what I'm doing. And here I could just use API version is equal to vk API. And since we don't care about cross-platform or whichever, I could just go with the latest and the brightest. Okay. Nice. Now let's actually go back to, well, in fact, before that, let me just define the extensions that we actually need. And the extensions that we need are, I believe, they're vk, well, hold on, vk surface extension, I guess. There you go. And then we need vk-khr. I don't know why it's not giving me. Weird. Oh my god. Well, vk khr XCB. There you go. Lovely. Nice. And there you go. Now we got the extensions down. We just need the surface extension, the XCB surface extension, and that's pretty much it. Nice. Now application info, and we just need the API version for the application info. The other stuff I don't really care about them basically. And now here there is the enable extension count, which is essentially extensions dot, I could say just 2, but yeah, anyways. And then here I need to cast, oopsies, oh well, static cast, is it? uint 32t and cast this guy, extensions dot size. And now enable extension names is equal to extensions dot begin. Oh, I guess I could just give it a reference maybe. Cannot initialize a member of subjective type with an R value. Well, I guess maybe extensions dot begin. Maybe that's how we do it, I guess. Okay, so yeah, I think that's pretty much all I really need here. Oh well, create info like this. For the allocation callbacks, I'm just gonna put it here as a kind of like, just gonna put it here. Just in case if I want later on to change the allocation callbacks to something, or for whichever reason, like for example for debugging the allocations, then I could easily change that. So yeah, const, and this would be like vk allocation, I guess, callbacks. There you go. And though it would be a pointer, though it would be a pointer, and it would be null ptr by default. Okay. And yeah, that's pretty much it. Allocation callbacks, create instance. And now we could actually check for the, now if this is actually, well, in fact, let me do the kind of trick. Const auto status. And basically, and you shouldn't check for if it's equal to 0 or not. Actually, you should check if it's less than 0, because if it's greater than 0, it's just kind of like an information or a warning, but 0 is of course success, but anything that is less than 0 is actual error. So yeah, now error vk status. Though honestly, coming to think about it, maybe I'd like to better off go with exceptions, really. Yeah, that's probably the most scalable option of doing it. Yes, I should go with that, honestly. Well. Let's see, well. has no effect. Okay. And here, all right, no matching member function. Oh, I guess logger error actually takes a non-const pointer. Yeah, well, that makes sense. Okay. So as you can see, it's nice to see which function is mutating which, but yeah. Error. Well, for now, I guess maybe let's just go with this simple solution. Honestly, you know, let's just go with class, Vulkan exception, and it would be public STD runtime error. And of course, for that, I need STD accept, I guess. Function with trailing return type. Must specify return type auto. Not class Vulkan. What? What is he even talking about? I guess I need a semicolon there? Weird. Okay, fine. So class Vulkan exception. And basically you're gonna have... Alright, we need the status. So integer status. And we need to... Oh, by the way, CD runtime error. Oh yeah, it's fine. Okay. And now here, I think I probably need to say this. I need to give it the message. Oh, I don't have really any message for now, though maybe later on we could try to I see. Could have like an auto translate maybe error. Or something like that. And then here we could have like a vacay. Is there like an actual type for it? Yeah, it's maybe vacay result, I guess. Is it? Yeah, it seems like. So, and then you could basically like switch on it. Switch on the result, and then for example, case of vacay like error, for example, memory out of host memory, for example, then you could like, let's say, return. Now I don't need the breaks, and then here I could just return unknown Vulkan error. Then here I could return out of host memory. Or just say unknown. Okay, that's pretty much it. Otherwise, instead of default, you could even go ahead and use, what is it called? STD enreachable, yes. Otherwise, you could just say, if you don't really care, then you could just say enreachable, I believe. Though I'm not sure in which header it is. So include enreachable. Hold on. CD enreachable. Basically, you could use this if you're sure that this can never happen, and the compiler can optimize on that. It's in utility header. Yes. utility, and then you could basically say unreachable. Though it doesn't seem like it works. I don't know. Okay, there you go. So we could basically say this too. But honestly, let's play it safe. And let's just say unknown. Alright, return unknown. And let's just remove the utility for now. Another common error, well, out of device memory, I guess. And you got the point. You could basically translate all of that stuff. Otherwise, there is another way of doing this, which is there is a header called in the Vulkan headers, Vulkan to string, I think. And let's see. No, I don't think it's here. Yeah, doesn't seem like it. Maybe vk result, vk success. Nope. Nah, it's not here. Though you could use this for some other things, seems like. I don't know why there's no vk result here, honestly, it's weird. Oh. What about out? Oh, there you go. There you go. So you could use this if you want, but this is a part of Vulkan HPP, and it's huge, as you can see here. So yeah, that's just something to keep in mind. Though you have to convert it into results, like static cast, or maybe even richer. No, yeah, just a static cast, essentially. But you got the point. Anyways, who cares? For now, it's fine. Where am I going with this? Projects, Docodox. Okay. Alrighty. Go back. And yeah, unknown or unimplemented. But anyways, so it's the runtime error, and then you could basically do something like translate error, or essentially, honestly, just say toString. Since C++, supports overloading, you don't need to go there. Anyways, so toString status, though I'm gonna make sure that it's a vk result. So it would call the write function. Okay, cool. That's the cd runtime error. And also I'd like to have like a private member called status, well, vk result, and then this should be public. Or let's call this result. Now this should be like this. Now also do this, and there you go. That's good. There you go. Private field result is not used. Though I'm not sure if I could say the same thing about XCB. Hold on a second. If I look into, for example, error, for example, this guy. Now I think it's maybe per error it is different, I guess. Yeah, possibly. So now you cannot should do a similar thing. Anyways. So what's happening here? Private field result is not used. I mean, yeah. I guess you could say get result, have like some sort of getter result, which would give back a vacay result, and that would just return result. And then you could basically handle use try except to handle some specific errors, essentially. But yeah, okay, and that's nice. Now what can happen here now is, let's remove this guy. Alright, so in this case, throw Vulkan exception. What's happening here? There you go. And give it the status. And there you go. Though, one thing, I guess it's const like this? No. It's here should be, I guess. Const, no except. And maybe this should be explicit, I guess. And yeah, that's pretty much it. That's the Vulkan exception. Now, what else? Status less than 0, then throw Vulkan exception status. And something is going weird here. Why you have this guy? Alright, so I guess that's it. Expected after expression. Oh, I forgot that there. Okay. And yeah. Yep. So now I could easily catch those exceptions whenever I want to. Anyways, so for now this is fine. Now let's see if the instance got created or not. So start. What's happening here? Okay, let's run this and see what's gonna happen here. And yeah. Nice. But let me check to make sure that that's indeed the case. So here, just make sure to either install the Vulkan SDK, or you could even install it. If you're on Arch Linux, for example, you could install Vulkan-Devil, which is the group of all the Vulkan stuff, which is quite lovely. So you could basically say, hold on, sudo pacman-s vulkan-devil if you are on Arch Linux, basically. So yeah. And then it would basically install all the things that is related to Vulkan SDK, like the Vulkan headers, the Vulkan tools, the SPIRV tools, etc. Though what I really need from this package is wiki-config. Okay, now this is a very useful tool for debugging Vulkan applications. So I'm going to go with API dump now. And let's just run this, and as you can see, I'm getting some output here. Oops. Where is the... There you go. As you can see, the API dump is telling me that, well, the wiki create instance is being called and it's success. Nice. And there you go, the extensions are right, they're being passed to Vulkan right. Lovely stuff. Pretty cool. Pretty cool. The API version. And something to keep in mind, by the way, is that a lot of times I actually fall into this trap, which is that, where's the API version? Hold on. Here. So maybe you could use like VK version 1.3 like this, which is incorrect. And this is actually just a legacy thing. It's just a compatibility thing. I'm not even sure why it's still there. Anyways, so VK API version, make sure to do that right. So in fact, we could even just say Vulkan API version. Auto Vulkan API version, and there you go. Nice. Nice. All right. What else? Though there's some other things that you could do, but you know, I'm not gonna go ahead and do that now. So now that we have the instance and the window, we could try to actually create a surface. So const auto surface, we're gonna go with, well, I guess it's, don't know the name actually. Well, I have to actually load it myself, right? So I forgot about that. So vk create surface, maybe XCB surface. There you go. That's the function that I need. So let's find out how I can load that up. So it's gonna be similar to this guy, essentially. But the type would be this, and the name would be this. And there you go. Of course, make sure to change the name here too. And used variable vk create XCB surface gauge r. Okay, so that's all right. As you can see, I've got the function now. Nice. I've just loaded it. Now I could pass in the instance, and I could pass in the create info and the allocation callbacks and the surface. vk surface gauge r surface. Okay, nice. Now let's see. Yeah, let's actually do this again. Let's say vk surface, well, actually vk, how do you actually, oh my god. There you go. And const create info. Okay, so here you give it the connection, which I already have. And oh, what's happening? No viable conversion from, oh yeah, I need to get it. And then what's next is the window. Though don't forget about the type, but yeah. So the window ID, I guess. Yes. And make sure to set S type too. So the S type is essentially vk structure type XCB. Oh well, I already broke. Bruh. There you go. And that's essentially how we do it. Pretty much it. But yeah, of course you gotta call the function now. vk create XCB surface, and then you're gonna get your surface. But of course, again, error checking. Bruh. Okay, then throw And there you go. Const auto status, blah 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 blah. Now we should have our beautiful surface. Though I forgot one little thing, which is here. I gotta say std scope exit. Well, not std, sr scope exit. Here instance scope, and let's just say reference. Vk destroy instance. Oh well, I have to load that. Yeah, alright, I forgot about that too. Yes. I need to clean this up, but alright, Vk destroy instance, and pfn Vk destroy instance, and here gotta give it the instance and the allocation callbacks. And there you go. And yeah, that's for the instance scope. Now another thing, which is the surface scope, same exact thing. Surface scope. I gotta make some wrappers to clean this up, but yeah. Alrighty, and I also have to load another one. Right, surface scope. pfn vk destroy surface kchar. Now you could basically go ahead, vk destroy surface kchar, and give it the surface. Though maybe also the instance. Yes. You also need the instance. And that's pretty much it. Nice. Nice. Though I'd like to load the destroy functions with the create functions. Why not? Though later on I need to actually make this into its own thing. And oh, I almost forgot. Yeah, I almost forgot though. Hold on, go back. Now the thing is, after we have created our surface, our instance, instead of null ptr, now we gotta pass in the instance. Essentially, I have to vk get instance proc adr, same thing here, and same thing here. And yeah, pretty much it. Now hopefully we got a surface, etc. So let's see, debug. Yo, what the? Oh, I see. As you can see, when I actually created the application, or when I opened the application, it created the instance successfully, and then it created the XCB surface also successfully, and then when I close the application, it destroys the surface, then destroys the instance, because we're using scope guards. So yeah, there you go. Pretty cool. Okay, so that's all right. So I gotta take a break for now, and see you after. Right, hello, I'm back. Alrighty. Thanks, Marty. Okay. Oh, why have this by the way like that? Interesting. Alright, well, where we was. Surface scope, status, error XCB. Though honestly, come to think about it, I think I'm just gonna get rid of SPD log as a dependency, and I'm not even gonna think about VMA. VMA because it, for now at least, it doesn't seem to work for me for whichever reason. Not sure why that's the case. There was that SNPrintf error, at least in Linux, though in Windows it worked, but I'm not sure why it didn't here. But yeah, honestly I think it's better to just reduce dependencies as possible. So we're only gonna depend on the Vulkan headers, which just are required. Otherwise you could use the system headers, but I don't wanna use that. So, and the scope guard, I'm gonna leave it for now until later on I work on my own one, my own scope guards. Be right back. Alright. So I'm going to remove this guy's never anyways. So I'm going to only keep scope guard and the Vulkan headers for now. Okay. And now I don't need SPD log anymore. I'm not sure do we even need stdio anymore. But anyways, so just gonna go with const int status in this case. Though honestly, while we're at it, why not just make a XCB exception? The problem with that, as we said, is that doesn't. But in anyways, we just gotta do it. So XCB exception. Though for XCB we're gonna get both a message and a result, I think. And it's not gonna be this guy, it's gonna be an int in fact in this case. Const int previous declaration. Huh? What? Oh yeah, XCB exception here. And toString result. Now I can't actually use toString because XCB doesn't seem to be having its own kind of thing. So, and honestly, I mean, coming to think about it, does really vacate create instance, for example, return? Hold on a second. Hold on. I think I'm doing it wrong. Oh, well, indeed, it returns vacate result, so that's nice. So yeah, it's fine. But for the other guy, like XCB has connection or whatever is it called? Where is that stupid thing? Hold on, let me remove this guy. Where's the XCB connection thing? Okay, there you go. It's an integer. Okay, so it just returns an int. Alright, cool. So, though we could do something which is like using XCB error is equal to int, and then that would work out just fine. So you could actually just say this, Now I could say XCB result. Although they're both integers, but since we have multiple type diffs, like different types or different type diffs, I don't know what you want to call it there, but aliases basically, we could use that. And now basically we could try to do whichever here, but in anyways, honestly, there's no need for now. Just remove that stuff, we don't need it. Okay, so here we're just gonna go with get the message, honestly. So get the message, how well message const char message, and there you go. Instead of vacant result, it's just an integer. And there you go, that's the XCB exception. Now here, instead of return, we're just gonna throw XCB exception. Though let's just call it XCB connection exception, maybe. Well, and in that case, I really don't need the message. I could use toString. Honestly, let's not overcomplicate things. You really just go with results. XCB connection. Sorry, XCB exception. And there you go. Just pass in status, comma message for now. XCB connection failed. Anyway, later on we may change that. Anyways, so other than that, what else? Use the find declared identifier logger. Okay. Now instead of logger, we're just gonna say std cerr, and we're just gonna say dlr, and just a new line there. Other than that, is there any other problem? Yes, here. So here we're gonna go ahead and say throw XCB exception, and we gotta give it the message, I guess. Failed to flush. XCB, whatever. Oh, I guess the message is second. Yep. Okay. Okay, no longer taking a break. Alright, well, what else? Now you can see that the function pointers is getting unmanageable real quick. And welcome back, Marty. Welcome. As you can see, the function pointer loading is getting messy real quick. In fact, everything is getting messy, but especially this guy, it's just gonna get messier. So I guess real quick for now, we're gonna have like a struct, and we're gonna call this, I guess, global dispatch, you know, and then you're just gonna have like pfn vk create instance. Okay, other than the global dispatch, well, I think I only need to create instance, in fact, in this case. So Then I guess pfn vk get instance proc addr. Okay, and now this global dispatch would, the constructor would take a instance proc addr, oopsies, hold on, and it would essentially go ahead and well, in fact no, we don't need this guy, just say get instance proc addr, and there you go. For that we're just storing it here, and the second one would be create instance. Now for create instance, it would essentially be, well, yeah, where is the create instance function? Here you go. So this is how you actually do it. Okay, reinterpret cast pfn vk create instance get instance proc addr, and there you go. That's essentially what is the global dispatch. Okay, pretty cool. Now the next thing would be the instance dispatch. No, maybe we'd like to call it Vulkan global dispatch, but yeah. Now Vulkan instance dispatch, it's actually going to be a little bit similar, though this time it's going to have, I think we're going to store maybe a reference to the global dispatch, maybe, or just move it. Not move. Yeah, not move. Just take a reference, right? So we could just store a reference just in case, I guess. Global dispatch. Honestly, let's just call it like that anyways. To be consistent. Okay. Now instead of global dispatch, we have instance dispatch. And so it's just storing a reference to a global dispatch, I guess. And then we're going to store the actual pointer function stuff. So if you have an instance dispatch, then you have access to the global dispatch essentially. So pfn vk, right. So what we need, yeah, destroy instance, that's the first thing that you actually need. So destroy instance. Next up would be, I need, well, let's see, pfn vk, create XCB create surface or something like that. Create XCB surface. There you go. Create XCB surface. And pfn vk. Other than that, there is destroy surface. Destroy surface. And then there's also, what else? I'd also like to have vk enumerate physical devices. Let's go, physical devices. And then there's also pfn vk, other than vk enumerate, Yeah, for now I'm just gonna go with create device directly. And then pfn vk destroy device as always. Oh, actually not here. So it pretty much ends up here for the instance dispatch. So yeah. Though this guy changes a bit. The other one is the actual device dispatch. And for the device dispatch, we're also gonna need some stuff. Now, the device dispatch would take a reference to the instance dispatch. Right. Instance dispatch. And then we don't know, I don't have this guy. So pfn vk and alright. pfn vk, my god, well, let's see. Destroy device, there you go. And then other than the destroy device, we have also vk get queue, get device queue, I think. We also need that. Other than that, we're also gonna need vk create, I guess, command buffer or something, command pool, yeah. So create command pool, and then pfn vk create command, actually not create, but in, well, let's start by destroy command pool, honestly. Destroy command pool, and then you got the pfn vk allocate this command buffers. Other than that, what else we're gonna need? Well, indeed, we're gonna need some other stuff. Right. Well, in fact, there is a lot that we're gonna need, but there's like create fans, create semaphore, create swap chain. Yeah, there's a lot. So for now, I'm just gonna stay with the device stuff, the simple device stuff, because at that point we're just gonna end up, I guess, the live stream, I think. And then maybe off camera, maybe I'm going to try to organize this and possibly abstract it. We'll see. I just don't want to bore you with that. Just, you know, wrapping stuff into classes, etc. Who cares? That's why I've done everything, almost everything in the main function. But anyways, so it's never boring. I don't know. Include. Let's see. So include what? Oh my god, my brain is lagging out. I'm experiencing some latency. Let's see. Like literally, what I wanted. What? Oh yeah. My bad. Alright, so I need the iStream for, yeah, I see. Include iStream and std accept. Okay, pretty cool. So essentially create instance. Though as you can see, well, in fact, let's just say static. And by the way, this should be public. Then this would be just a little helper function. Static, Lloyd, procedure, I guess, or well, anyway, just call it Lloyd, I guess. And then here it would have like, I guess, template maybe. I even forgot to do templates. So type name T, I guess. So Lloyd, and you would essentially get the T, and you'd need to give me the pfn vkk instance proc addr, and the name, of course. So const char name, and that's pretty much it. Though instead of const char name, we could go with std string view. So yeah, view name, and yeah, now we're just gonna return this reinterpret cast blah 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 blah. And just return, here is the T, and here is the name. Though honestly, since we're not gonna, you know what, never mind, just say const char. So yeah. Other than that, type specifier is required for all declarations. Yeah, static auto. And there you go. That's pretty much it. Now, instead of this craziness, I could just copy, well, here's the deal. Just gotta remove all this stuff and just say Lloyd get instance proc and give the name. Though we also need the template, of course. pfn, oh, not here. Lloyd pfn vk create instance. That's essentially it. Though, can't it just like deduce from the return type? Well, that would have been cool. But anyways. Alright, comma. And I think that's all I need currently. Just create instance function. And yeah, we're gonna have something similar in the other guys. Lloyd, but in the instance dispatch, we're gonna need the instance. So for the instance, we're gonna go with pfn vk. Oh, what I'm doing. vk instance, actually, you need the instance this time. So instance use parameter, sure. And here you gotta pass in the instance. That's pretty much it. Now let's remove this craziness, or let's just change it with other stuff like destroy instance. Honestly, let's just start it from scratch. Okay, so here we need to get instance. Well, in fact, we need the oh my god, come on, let's just do it here. So Vulkan instance dispatch, and here's the deal. So global dispatch, this would be, well, global dispatch essentially. As simple as that. And it would be like a const reference or something. Yeah, I mean, we can, I guess, do const here. Though I wonder if I can just make it all const. I don't know if that would work out. Let me see. For example, here. Would that work out? I mean, seems like, I guess. Yeah, seems like. I guess that works. Vulkan instance dispatch. Alright, cool. Now, I think honestly, I'm gonna have also like a public function to Lloyd. Now this is gonna be an actual member function. So auto Lloyd also gonna take a template type name t blah 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 blah, I guess. Is it? No, why? Hold on. No, it cannot actually, because it doesn't have like the instance, so it's kind of useless. Yeah, I bet. Alrighty. Do I wonder if we want to like store the instance too? I guess, why not, I guess. But yeah. So basically you get the global dispatch and then you get the instance. Is it? And then you essentially get the instance. You store that. And now I could basically go ahead and load the other stuff. So destroy instance would be Lloyd. Oh well, pfn vacate destroy instance. And then, oh, I don't actually need to get instance proc anymore, no? Oh, the get instance proc, I see. So I actually do need that. Well. Interesting. So we do need that. Okay. Auto Lloyd. And it's just gonna contain the name. Because we already have get instance proc addr. Actually, I also need the instance. Yes. Also need the instance. Yeah, it's crazy. Right. Right. Template, of course. This would return T. Though I cannot have both like that. I guess let's call it Lloyd proc or something. Let's call this Lloyd proc, I guess. Lloyd proc instead, so they don't, conflict. Alright, and now I'm just gonna return, let's see, I guess Lloyd proc T, and it would just contain get instance proc addr, and then, well, instance common name. I guess that's basically it. So, well, there should also be Lloyd proc. And here, essentially, it's gonna get the, well, honestly, I think let's get the instance first. Yeah. Right. Oh no, that's not how it actually works. Is it? Yeah, what I'm doing. I'm doing something weird here. Lloyd proc. What in the world? Yeah, my brain is shutting down. No, that's not how it works. Okay. Gotta do it like that, and then also reinterpret cast here. Yep. Okay, that's how it should work. Ah, it's weird. Okay. Alright. Instance name. Now this is kind of confusing. So to Lloyd vacate destroy instance, we need the actual instance. And we need the global dispatch. Okay, global dispatch and instance. So in this case, it's gonna be like global dispatch, I guess. Dispatch const. And then here we would just say dispatch. Oh, okay. And now we could just say dispatch.lloyd. The name T. Yep. Candidate function template not viable. Though other than the name, we also need the instance, right? Bruh. Why the warnings are... How am I supposed to even read that? Has type const, but method is not... Oh yeah, I see what's going on here. So Lloyd const. This should be const. Maybe even no except, but yeah. Alright, so that works now. Finally. So dispatch the Lloyd T instance name, and now here you just use that Lloyd proc pfn vk destroy instance global dispatch instance vk destroy instance. Oh well. Other than that, we gotta say create XCB service, I guess. Alrighty, and copy this. And that's basically should happen for every single stupid function. We could use Python to generate this, but well. Enumerate physical devices. Oh my god, that is another level. Destroy surface, bfn vacant destroy instance, destroy surface ghr. Or maybe I guess I should use some macros. pfn vacate destroy. I mean, honestly, would that work out for us? I mean, if I say... Is it define? Lloyd the name, and then it would be just, oh well, it wouldn't work because, well, we're using a custom name. Oh my god. Oh well, you know what, never mind, for now this is fine. Okay, anyways, we could destroy service KHR. So tedious. And finally create device. That took forever. Create device. Oh, where is... Oh, well. I see, okay. I think that's pretty much it, hopefully, for the instance dispatch. I probably screwed something up, but anyways. Public. Oh well, in fact, it's already a struct. No need for public and private, and in fact, it's all public. Yeah, it's all public, so that's why I use struct. Alright. Now the Vulkan device dispatch. Let's see. So you're gonna need the instance dispatch, also vk device. Though honestly, you know what? No need to store the device in the instance, really. Yeah, like probably we're gonna make like an instance kind of class later on, and it doesn't really make any sense. There's, yeah, pretty much, honestly, no need to store it. Yes. Though, I mean, if you want to, I don't know. Anyways, never mind. For now, this is fine, okay? Just remove that guy. Keep only the Vulkan instance dispatch and that guy. Okay, cool. So now Vulkan device dispatch. Oh my god, I'm gonna do that stuff again. But yes, it's similar, pretty similar to this. So vk device this time. Now the device. All right. Now before we go into that, let me first of all make this function that we have here. But before we can do that, we have to first of all define this member function. All right. Now instead of get, oh yeah, I forgot about vk get device proc. Alrighty, well, interesting. Here there's like Lloyd vk instance. And I guess here there would be like a vk device, right? Yes. And then instead of get instance proc addr, we're gonna actually need to after create device, I guess we're gonna have another guy, maybe vk get device proc addr, I think. That requires a device and the char. All right, cool. So now we're just gonna do something similar to this, and basically get device proc addr pfn and then oopsies, do it like that, and there you go. That's the get device proc addr. Now we're just gonna use get device proc addr instead, and this is not an instance, this is a device. Alrighty. Now we're just gonna have something similar to this now. Here, Lloyd proc. This would need the instance dispatch. And it would need the vacate device. Need device. Then const char name. Yes. Device and const char name. Now here we're gonna go with device. And there you go. That's it. Now we could just make ourselves this guy. Actually, I don't need it. I mean, well, anyways, okay, so let's just try now to actually load these guys. It's pretty similar to this, though instead of that, you're gonna go with, oh, by the way, did I didn't, yes, I didn't, interesting. Instance dispatch, and in fact this should be Vulkan instance dispatch. I probably missed a lot of stuff. Anyways, so instance dispatch, and this is also should be called that, and this, and now destroy device, vacate destroy device. I should probably make a script, Python script, to automate this later on. We can do that, that would be nice. So yeah, anyways, so get device. Oh my. Destroy device, and then get device queue. pfn vacate get device queue. Now Vim users are probably laughing at my mouse skills. Okay. Let's see, vacate get device queue. Nah, instead of global dispatch, well, instance dispatch, instance dispatch. And yeah, that's pretty much it, hopefully, for that one. Hopefully I didn't make any mistake there, which I probably did. Anyways, can I do const here? Here. Yeah. Seems like. So that's pretty much it, I guess. Now, instead of loading those functions ourselves, here, actually, let's see. Now this is fine, but yeah, this guy. So instead of create instance, we're just gonna say const auto global dispatch. Okay. Anyway, I'll just call it global dispatch. Okay. Vulkan global dispatch or whatever. And here you probably need vacate get instance proc addr, if I remember. And there you go. Now, instead of this, you would say global dispatch dot create instance. There you go. Now same thing with this. In fact, I don't need this. It's already loaded. So, but here we gotta say again, global. Actually, before that, so after creating the surface, what I gotta do is load the instance dispatch. So how are we gonna do that? Well, nah, no need to do that. Okay, let's just do it here. So const auto instance dispatch, and you would basically get here, let's see, Vulkan instance dispatch. Now here you just gotta pass in the global dispatch, and of course the instance that you have just created. And there you go. Now essentially instance dispatch dot destroy instance. There you go. Now same thing with this guy, remove this guy, and essentially instance dispatch dot create XCB surface. I don't need that too. And basically instance dispatch dot destroy surface. And yeah, that's pretty much it finally. Alrighty. Okay, what is wrong? Expected. Use of undeclared identifier. Ooh. Device. Yeah, copy pasting is bad. Yeah, we're not linking to SPD log anymore. We got rid of that dependency, and probably also gotta get rid of scope guard later on. Maybe. I don't know. We'll see. Okay. Okay, let me make sure everything is fine. Yeah, I guess seems like. Then when I close this guy, as you can see, destroys the service, destroys the instance. Nice. Amazing. Pretty much the same thing, but right now it's a bit more interesting and easier to abstract. So anyways. Okay, cool. Now, I'm just going to try to create the device, and pretty much going to end the live stream. So the device surface scope. Let's see. Okay, so vacate device vacate device, right? And then, well, in fact, before the device, I need first of all the vacate physical device. Now, I'm not gonna go crazy about this. I'm just gonna select the first physical device. And it's pretty simple to do that. You're just gonna say uint 32t physical devices count, or just call it count, honestly. Yeah, and then just say vacate. Well, in fact, the count would be 1. I only interested in the first physical device, so why bother getting the count and then do all that crazy stuff? So here's what I'm gonna do. I'm gonna say instance dispatch. How do you do that? There you go. Now dot enumerate physical devices, and then just give it the instance, give it the count, which is in this case 1, then give it the physical devices. All right, physical device. And of course the error checking stuff. You got the point. Alright. And there you go. That's how you get the physical device. There is some other crazy things that you could do, but I'm just going with the simplest way of just getting the first. Cannot initialize a parameter of type uint32t. Well, can't be const, I guess. Yeah, there you go. Alright, so other than that, also the Q family, uint32t, Q family index. For that one though, for now, I'm just gonna go with the 0, the first Q family, which is usually the thing. Usually the first physical device and the first Q family index are the right ones. So who cares? Okay, in used variable. Okay. For now, it's gonna be const. Later on, who knows? Anyways. Other than that, now we're basically ready to create our physical device, our device. So how are we gonna do that? Well, well, anyways, make a device. And finally, let's see what we can do here. Boop. Then instead of this, you gotta go with the create device. And here you would probably need the physical device, I guess. Yes. The physical device, okay. Then the device create info. And the allocation callbacks. What else? And then you just get the device. Okay, cool. Cool. So now I just need to define what is the create info. So for the create info, it's basically vk device create info. But before that, honestly, let me just go with q. Well, device q create info. And with that out of the way, let's see, dot, bruh, why it's not giving me, oh yeah, q create info. Now you could request multiple queues, but and even you could create multiple devices, all sorts of craziness, but I'm just limiting my scope here. So yeah, queue count, just gonna go with 1. And then the queue priority is gonna be priority here, which is just gonna be a const float priority. Doesn't matter what you set the priority in this case, since we have 1 queue, so you don't have anything to prioritize. Okay, there's 1 queue, so okay. Other than that, you have the Q family index. Oh well. Okay, this is the right order, seems like. The other thing is S-type. Oh my god, I probably forgot a lot about S-types. So vk structure type q. Huh? There you go. Now of course S-type should be first. Now we're done with that one. Other than that, we need the extensions that we're going to go with, and yeah, I'm going to go with 1 extension, which is the swap chain, pretty much. Yes, swap chain. So yeah, let's just go ahead and create now the device create info. Is type vk structure type. Yeah, it just doesn't work. Stupid. Anyways, right. Device create info. The IntelliSense is so bad, honestly. Anyways, never mind. Unused variable. Q create info count is that, and then Q create infos is Q like this, I guess. And then what else? I'm getting some crazy weird stuff. Anyways, dot enabled extension. Come on, I'm getting some glitches of rendering. I guess I gotta create my own editor now. Oh my god. Anyways, pp enabled layer count or extension count equal to 1, and then enabled extension names. Just gotta go with, well, I cannot do it that way. I need to do it this way, and I can just say const auto extension. Now vkkhr swap chain, and there you go. I think that's all I need. Yes, I think so. I think so. Now, other than that, okay, now we gotta actually load in the device dispatch, basically the device functions. So device dispatch the device. Oops, what I'm doing here. I need though the instance dispatch basically. And then the device. Essentially. Alright, cool. After that, what? Okay, right now after that we're gonna say sr scope exit. Well, I'm just gonna copy this guy. Hold on, there you go. Something like this. Now device scope. Now device, well, basically device dispatch, destroy device. And yeah, it seems like you just need expected to have 3. I guess you just do this, and yeah, that's pretty much it, I think. So now let's try to actually run this guy. So as you can see, we're creating an instance successfully, and we're also creating an XCB surface KHR successfully. And then when I close this guy, oh, by the way, where's the device? Did it really create the device? Huh, interesting. No, it didn't. Am I missing something? Oh my god, what do you mean by instance this? Oh yeah, it's fine, yeah. So what's the problem here? pfn vk create device. What the? Hold on. Can I do this? Debug mode. And let's see what's happening. How can I watch some value? I mean, it seems like the device is there, but I'm not sure why the VK API thing didn't really catch it. Weird. Okay, what happens when I actually stop the thing? Oh, actually, there you go. VK create device. I don't know why it didn't before. But let's go. VK success. There you go. That's what I'm talking about. But where is destroy stuff? This is oh yeah, there you go. VK create XCB surface gauge. Okay, let's try again. Hold on, let me remove all this stuff. Oh yeah, now I know how to actually remove that thing. Interesting. Okay, so they were all running all this time. So this is the application output. As you can see, we're creating the instance successfully. Create XCB surface, enumerate physical devices. We're given one physical device. Creating the device successfully too. And then when I actually close the window, oh, why it doesn't work? Interesting. So when I stop this, oh, I see. Well, why? Weird. Let's see. Client message. So it wasn't closing all this time for some reason. That's super weird. Well. Okay, let me try to run it again. What? Now it works? I have no idea what's going on. Sometimes it works, sometimes it doesn't. Interesting. But anyways, so as you can see, it's actually destroys when you close the window. It goes ahead, destroys the device, destroys the surface, then destroys the instance. There you go. No memory leaks. None of that. Pretty cool stuff. And no handle leaks. Everything is pretty cool. Alright, so yeah, maybe off camera I'm gonna try to organize this and abstract it into classes. And yeah, we'll see. I'll see if I can do that. Other than that, so yeah, that was it for this live stream. It was already how much time? Oh my god, 5 hours. Okay, so yeah, that was pretty much it. Any last words? You're welcome, Marty Flowers. Thanks for being the most active viewer. Right. And also thanks for recommending Qt Creator. So yeah, pretty much. Alright, so that was it for this live stream. My brain is lagging out at this point. So yeah, see you later. Goodbye everyone. Thank you for watching.